Most people think estimating is just measuring quantities and applying rates. Well, it's not. It's a complete system for how construction companies secure profitable projects, and it requires a comprehensive understanding of different construction methodologies, contracts, and business strategy. In this course, I'm going to take you from someone with zero estimating experience to be able to put together comprehensive estimates and bid submissions to help you secure profitable construction projects. You'll understand how to prepare a price that aligns scope, risk, methodology, and contract conditions. So we're going to cover absolutely everything. We'll talk about why estimating matters and where estimating goes wrong, the complete estimating process from the original receipt of the tender documents to the final submission, the different construction estimating methods and when to use them, understanding different buckets of construction costs. Then we'll talk about the full process to calculate direct construction cost, including labor, plant, materials, and subcontractors. Then we'll talk about how to calculate overhead or project running costs, before finally how to review and check your estimate for errors, and most importantly, how to prepare a comprehensive letter of offer to submit to your client so you're both managing the estimate, but also the terms and conditions that surround your price. We'll also briefly discuss customizing the estimating process to the specific type of business that you're working for. My name's Tim, and I spent the last decade working on mega construction projects before more recently working as an estimating and contract management consultant. Recently, I've launched my own estimating and contract management platform called Operum. You can check it out and use it for free. And my YouTube channel is really all about exploring what tools and processes actually work in construction to help construction companies make more money and run more successful projects. So first up, let's dive into understanding why estimating matters and why it's the backbone of any successful construction company and construction management career. Estimating matters for the simple reason that money matters. Any construction project or the construction industry more generally exists to create value. That value is always going to have some sort of cost associated with it. We can build a solar farm to generate renewable electricity, but the cost of building that solar farm is always going to be relevant to talking about how much electricity we can generate and ultimately if the project makes sense to do. So really with every construction project, we want to build something useful at a cost that makes sense with our ethical responsibility as construction managers to make sure we do so without hurting anybody. Basically, if the numbers don't stack up, if we can't build something useful at a cost that makes sense to do it, the project shouldn't proceed. Estimating fundamentally is how we test whether or not we should do a project. Now, extending on this concept, estimating isn't a calculation process. It's not just taking a set of plans and specifications, plugging them into a calculator and generating a cost. Estimating is a much more complex process than this. As we all know, construction is ambiguous and uncertain. It's full of risks, assumptions, things that are clear, things that we don't know at the time of pricing, and it is highly commercial. You can perfectly calculate the cost to do a project, but ultimately still lose money on a project. I think of estimating more as interpreting and understanding different construction methodologies and tasks, making judgment about the best ways to do things, how accurate the information you're relying on is, and how to qualify that. Basically, how to understand risk and uncertainty and how to factor that into your price. And ultimately, it's about business strategy. How, as a construction company, do you win profitable projects in a highly commoditized market? Really, estimating is a much more holistic field that talks about how we either win or pursue projects that make sense for our business. Now, here I'm going to talk about estimating from both the perspective of the project owner or project developer and also the contractor, because both project owners and contractors employ estimators, but the majority of this course and my own personal background, I'm talking about estimating from the perspective of a contractor. The process is relatively the same, but here I think it's important to talk about estimating from both these different perspectives. But in terms of the overall course content, it's very much focused on estimating from the perspective of a contractor. Okay, so from the project owner's perspective, we need to understand this fundamental relationship between value and cost. It is only worth building something of value if we can do it for a cost that makes sense. When we're talking about the role of project developers and owners, basically they're working out what we should build and they need to understand the cost of building it. If you're talking about a private business deciding to deliver a project like a toll road, a solar farm, they need to understand the profit they're going to generate over the lifetime of the asset and then the initial capital cost to build it. If we're talking about a public developer, so say a government that wants to build a hospital, they need to understand the utility and benefit of that hospital to society. They also need to understand the cost of doing it. Cost is always going to be the counterweight. There's always going to be some value generated by something and some cost associated with it. For example, from the perspective of a government, a freeway that solves congestion is in theory a fantastic thing to do. But a freeway that costs $1 trillion wouldn't be a fantastic thing to do. There's probably much more cost-effective solutions to this problem. So the core principle is that even good ideas become bad at the wrong capital cost of pursuing. So fundamentally, when we talk about the role of an estimator at a project owner, they're using estimating to decide what is the cost of building something and does it make sense to do it. Now, from the perspective of a contractor, estimating is about survival. The contracting business model is you quote to do a project. So you quote to build a road for a project owner. You charge them $2 million. It costs you $1.8 million to deliver. That 200 grand difference, that is the profit of the business. The whole contracting business model relies on being able to accurately understand your costs of doing the work. If you quote $2 million to do the project, but it actually costs you $2.1 or $2.2 million, you are losing money by doing the project. Considering construction has razor thin margins and everything is highly commoditized, meaning there's lots of other contractors likely bidding for the same project, being able to properly understand the cost of doing the work highly accurately to plus or minus 5%, then being able to confidently quote to do that is essential to the survival of any contracting business. If you're not doing fixed lump sum contracts, then really you're a plant or labor hire business. You're not a contracting business. Fundamentally, bad estimating leads to underquoting. Underquoting leads to contractors going broke, which really ties into this next point I want to make, that estimating is really a business game. It's all about the business strategy and the context of the project. You're not pricing in a vacuum. Estimating isn't a calculation exercise. When you're pricing a project, you really have to consider the market that surrounds the opportunity that you're pricing. As I've said, construction is highly commoditized. Most projects, your clients will go out and get 5 different quotes. They'll compare them and they'll likely choose the lowest price. Now, what makes this worse is the lowest price often isn't the person with the best methodology or who can actually do it at the lowest cost. It's the contractor who's missed things and underquoted. What this means, and it's a depressing truth about the construction industry, is that if you know exactly how much something costs and you price it accurately, you probably won't win the bid. Now, that's going to be true in the competitive markets. Obviously, if you're in a market where there's much less competition and you've got pricing power as a contractor, then that's an amazing thing. But a lot of the time, contractors are operating in highly competitive, commoditized industries. So basically, if you understand exactly how much things cost, you can take much more strategic risks and gambles. You can also better qualify and manage your price and play the contract management game to basically set up qualifications and protect yourself from risk. And ultimately, you can more confidently submit low prices that you know you can stick to and that you have opportunities for profit built into them. So really the key point I'm trying to make here is estimating is not just a calculation exercise, it is a strategic business process. So we contrast good and bad estimating. With good estimating, we're winning the right jobs, we're pricing risk consciously, we understand how to qualify and manage our bid submissions, it supports value engineering and cost-saving opportunities. We're going to win profitable projects. Good estimating wins a good business. On the other hand, bad estimating, we're either going to price too high and never win work, we're going to price too low and win bad work, we're going to miss profitable opportunities because we haven't qualified our price properly. Ultimately, we're going to get into these battles with our clients, we're going to piss them off, and at the end of the day, bad estimating means bad business. Now, while I've spoken mainly about estimating in the role of pre-contracts and identifying profitable projects to pursue, really estimating is more than just a pre-contracts function. I'm not going to talk about this too much in the context of this course, but the same estimating principles and approach you apply here, you can apply it across the entire project lifecycle, including in value engineering. So identifying cost savings through both design, construction methodologies, developing your procurement strategy, understanding how your subcontractors are pricing stuff. That's actually going to help you with subcontract management, checking variations in claims, but also helping you prepare variations and claims to your client, managing contracts, and ultimately support your cost control and forecasting. Basically, if you know your numbers, you understand how they're put together, you understand how they relate to the project scope and the context of the project. Basically, it's going to support the entire project lifecycle. Now, the bit you probably care about is, why does this matter for you? Well, for employees, money literacy is ultimately going to be leveraged throughout your career. You look at every senior manager at your construction company, the one thing they know unbelievably well is how much stuff costs and different numbers that matter. Because ultimately, once you get to that level, business is about budgets, profitability, and loss statements. And in construction, estimating is how we understand costs. Even if you aren't actually working as an estimator, if you're a project or construction manager or a project engineer, basically estimating is going to help you make better and more informed decisions, understand how things cost, but not just for the specific task, but in the context of the overall project, improve your contract management drastically, help you identify value engineering, and basically it's going to help you manage risk and impress your management. Really, understanding estimating is going to change how you think about the role of construction managers. Now, for business owners, all I'm going to do is repeat what I said before, but estimating is going to help you decide what work you win, whether you should pursue projects, what projects you should avoid, and ultimately be the driving force behind whether your business succeeds or fails. Next up, let's work through the estimating process. Here, I'm going to talk about the entire process of how we go from getting bid documents or a tender package from our client and how we turn that into a commercially viable price and solution. The purpose of this section is really just to give you an overview of the entire process, which is going to help the further modules of the course make much more sense. The further modules of the course are going to be where we get into much more detail about things like calculating specific productivity rates, how to come up with different labor costs, how to get accurate subcontractor quotes and include them in your bid. That's all going to be covered later on in the course. This section is really just about understanding the overall process and how everything fits together. And really, I just want to keep stressing the same point that estimating is not just calculating a number. It's about understanding our scope, risk, commercial terms, how that relates to our cost, and then coming up with a price and terms and conditions that surround this price that we're comfortable for submitting to a client. All right, so the first things I want to establish are the outputs of the estimating process, and it's not just the price. The price is one output, but really there's three key outputs of any estimate. We've got the price, the calculated contract value we submit to the client, which is built from our quantities, our rates, assumptions, and risk allowances. That's the dollar value associated with our estimate. The next thing is the variability in this price. So this is our accuracy or uncertainty. Now, typically in the industry, people refer to this as a class of estimate, but I just like to think of it as a variability. Because at the end of the day, any estimate is reliant on our input assumptions and qualifications and the level of data that we had when producing it. So very early on in the project, we may only be able to produce a concept or order of magnitude estimate if we have a poor quality of data, only early stage concept design drawings. We then would go through feasibility where we're adding more detail and design to the project. Therefore, we can produce a more accurate price, then a budget estimate, and finally a tender or definitive estimate, which I refer to as a contract value. And basically, this is always going to be a function of the quality of input information, the level of design completeness, what our subcontractors and suppliers, how much certainty they're giving us around their prices, and finally, the time pressure we're under. If we don't have much time, we can only prepare a concept estimate. Got a lot of time to go through and prepare a detailed estimate. Obviously, going to be able to reduce the overall uncertainty. Key point here, that we can have two prices that are the same, that have a different level of variability associated with them. Now, the most important thing, and what I always go on and on about, but tons of people ignore this, the terms and conditions that surround that price. This is what is included, what is excluded, what information we've relied on, Did our client provide us a bill of quantities, or have we gone and measured the quantities ourselves? The key assumptions, all the qualifications and clarifications that surround our estimate. A price without terms and conditions is fundamentally meaningless. All right, so now we understand the outputs of this process, which are the price, the uncertainty, and the terms and conditions that surround it. Let's talk about the inputs to the estimate. For pricing anything, our estimate is fundamentally influenced by two key categories. The technical inputs to the estimate, which is our client-provided tender documents, which is going to be the same between all the contractors quoting the jobs, and then also our commercial and strategic inputs, which are specific to us as a contractor. A price that makes sense for contractor A might not make sense for contractor B. Okay, so when we talk about the technical inputs, these are the tender documents, like the drawings, the specifications, the scope of works, the contract conditions, a bill of quantities if the client's provided it. Then we've got our contractor-specific commercial and strategic inputs. These are things like the market conditions, the level of competition, how good our relationship is with the client we're doing the work, how much they want to give us the project. So obviously we've got a good relationship with them. We've got opportunity to have a higher price, our risk appetite, and also importantly for a lot of companies that own a lot of plants or have a large workforce, you'd want to consider the availability of these resources and the workload. If you're super busy, you don't have much availability, you'd probably be wanting to price higher. If you've got a lot of resources and no job to allocate them to, you're probably more desperate to win something. Now, let's talk through the estimating process. How do we go from these inputs to this output? So the first step in the tender process is simply to digest and understand the documentations you've been provided and exactly what your client is asking you to price. Don't start with the drawings. This fundamentally starts with the contract and the scope of works. What is your client asking you to price? What are they asking you to exclude? What information are they giving you? Are there conflicts between documents? Are there things that aren't clear? Then, based on having an understanding of the scope and what you're being asked to price, you can review the drawings with this as context. Now, the output of step one will be any clarifying questions that you need to ask your client to resolve, so RFIs, but also your assumptions and clarifications. How are you proposing to price the project? And you should also have a key understanding of the risks and opportunities associated with the project. Something I see a lot of estimators do is to sort of exclude the contract side of it. They just think of pricing as this exercise where they get the drawings, measure the quantities, apply the rates, look at the productivities, blah, blah, blah. You can't ignore the contract and the scope of works. They're fundamental to how you prepare an estimate. So I would always start by looking at the contract and scope of works. What is the client asking us to price? And using this understanding, I then review the drawings to understand the technical scope and the methodology. Step two in the estimating process, once you understand the scope, is to set up the estimate structure and pricing schedule. This is where you want to break the project scope down into a set of activities and build a clear pricing schedule that covers the entire project scope, so every single task you're going to be doing, in a clear and articulate way that describes what is included and excluded in your price. If you're a general contractor that subcontracts out the majority of the work, you would also want this to align with your procurement strategy. Ideally, you would have the line items that reflect specific subcontractor scope. The end exercise of what we're doing here is we're taking the client requirements and we're breaking this down into a pricing schedule, which is the structure of how we're going to prepare the estimate. The client may have given this to us, or it may be something we are producing. I also like to ensure that when I'm creating a pricing schedule, it reinforces exactly what I'm pricing. This is going to be the key document for how our client reads and interprets our scope of work. For example, if we're pricing labor only to place concrete, I would say in the pricing schedule something like labor to place concrete and the volume of concrete associated with that. Clearly from that line item, there's no ambiguity. You can see it excludes the concrete supply. So really, the pricing schedule, it's going to be the key way we check that we're pricing the entire project scope. It's going to help us define and understand the scope. It's going to be to help us manage the risk and uncertainty with our price by showing things like quantities that we've relied on and used, but also to communicate our scope to the client. Now, there's two different buckets of costs you would include in your pricing schedule. I'm not super happy with this terminology, but it's a terminology I've settled on and it makes sense to me. I'm still like a bit torn whether to go and change this, but it's the terminology I use in Opera. But basically, I break the pricing schedule down into direct costs, which are costs that we show to the client. These would be things like the key construction activities, maybe project management and overheads, basically anything we want our client to see in the pricing schedule. We've also got our indirect costs. These are costs that we don't want to show to our client, but we need to include in our price. So these might be things like risk or weather allowances, supervision, other overhead costs, maybe temporary works if we don't want our client to see that line item in our schedule. We classify these as indirect costs. These costs are spread across our direct costs. The direct costs are the cost our client is going to see. I personally can't think of a better description of these two terms, but I am slightly conflicted with it because sometimes I also use the term indirect costs to describe a job running cost not directly attributable to a specific scope of work. So for example, project management would be an indirect cost to me. But project management or preliminaries might be something you want to show in your client pricing schedule so that you want them to actually see the line item or the cost associated with that. For example, if you've allowed for 8 months of a project manager and you're relying on their schedule, I would show in the pricing schedule preliminaries or project management for 8 months because that's going to help you justify any contractual claims you make later. So really, maybe I'm massively overcomplicating this, but when you do your pricing schedule, there's construction tasks and activities you want your client to see, and then there are ones that you wouldn't want them to see, like risk allowances or weather contingencies, which you would spread across those other items. So at the end of step 2, what do we have? We've got a clear estimate structure. We've broken down the project scope into line items. We've got a pricing schedule that clearly defines and articulates what we're pricing, and we've got some separation between stuff we want our client to see and stuff we don't want it to see. Now, here comes where the bulk of your time is going to be going, which is our actual cost buildup. So for each line item in our pricing schedule, which we know is 100% of the project scope and what we're pricing, we basically have to work out how much it is going to cost to do that piece of work or that activity. And we just go through the entire pricing schedule, and using some workbook structure like this, we apply quantities, rates, build up all the resources required. Any construction activity is going to be a function of the delivery methodology. This would mean whether we're self-performing the task, employing our own labor, plant, and materials to do the work, or we're engaging a subcontract on a lump sum to do it. We can also have hybrid methodologies like a schedule of rates contract where we're responsible for the quantity or overall volume of the work, but our subcontractor is providing us a unit rate, or really any sort of hybrid methodology where we might free issue them the materials, but then they do the actual labor and plant on lump sum. But basically any direct or indirect costs we can really break down into a function of our labor, plant, materials, subcontract, and overhead costs, and there'll be some sort of quantity, productivity rate, duration associated with these tasks. This step is where we really go through the drawings, we measure all the quantities, we apply productivity rates, we can then convert these quantities and productivities into labor hours, plant durations, crew sizes, durations, basically build up our costs. Now, I'm going to go into way more detail in the course on how you actually calculate your labor, plant, materials, subcontract, and overhead costs, but really it is sort of pretty intuitive. For each of these items, there'll be a quantity and there'll be a rate. You need a project manager for 8 months. You need 2,000 meters squared of formwork. Basically, anything we're just going to break down into a quantity and a rate. Yeah, so I'll show you a quick example of both a pricing schedule and some pricing workbooks in Opera just to show you what I'm talking about. And again, I am going to keep shamelessly plugging Opera throughout this entire video, but I do think it's good, and this estimating feature is completely free to use. The way it works with our pricing schedule is we've broken down the project scope into all the tasks we're taking to do the project, including our preliminaries shown as a separate line item, and then we've got our indirect costs shown separately as well. So indirect costs would be the ones we're not showing our client, our insurance and permits, our inclement weather, and then we've got our sell price for our direct costs, which has these indirect costs spread across them. Then each of these tasks, we have a pricing workbook. Pricing workbook, again, is just a combination of different rates and quantities. For example, if I'm pricing 1,000 meters cubed of concrete, my quantity of concrete is 1,000 meters cubed. I need 500 meters squared of formwork. So I've got a rate for formwork, which is $100 a meter squared. and I've got a quantity of formwork, which is 500 meters squared. I need a concrete pump for 10 hours to pour this. So I've got a rate of a concrete pump, which is $300 an hour, and a quantity, which is 10 hours. All these rates will come from some sort of resource library that you have, which would include quantities, plant rates, labor rates, subcontractor rates, whether it's a lump sum or they've given you a schedule of rates. All these different items would be in your resource library. And then really the actual estimating calculation process is just going through and for different activities working out how much of that you need and how much it's going to cost. So for something like concrete, we've got our meters squared of formwork, the labor and materials associated with that quantity of formwork. We'd have our reinforcement, which might be tons of steel, and then there would be some productivity and number of hours associated with that, or we might get a subcontractor who's just installing that on a per ton basis. For concrete, we'd calculate our meters cubed of concrete, how much we need to supply, how many labor hours to place, and whether or not we need a pump. For our indirect and overhead costs, these are the same. They're just a quantity and a rate. The key difference here is for our indirect costs, for recurring overhead costs, these are going to be driven by the duration of the project. So we need some way of estimating or quickly working out the overhead duration, which I'll talk about in more detail in the indirect and overhead cost section of this course. Some of our indirect costs may also be driven by the contract value. For example, unknown risk allowances will usually be a percentage of the overall cost of the project, or things like allowances for subcontract coordination, variations, and delays would be proportionate to the overall subcontracted value of the project. When some indirect costs will just be one-off non-recurring costs, such as site setup costs, which we would price using the same approach as a direct cost. So because a lot of our indirect costs will be proportionate to items in our direct costs, we would always price our direct costs and then price our indirect costs. Once we've prepared our price, next we need to review it and check it's correct. At the end of the day, a bid you submit is in some way a bet on your business. If you underquote a job badly, contractors often do go broke. So having a process to how you check and review your estimates is fundamental to the estimating process. The checks I would always do would be some sort of scope coverage check, some document compliance check, some quality or sense checks. So looking at high level numbers to make sure that makes sense. Look at your labor, total man hours you've calculated. How does that make sense in terms of number of crews and duration for work? Basically doing a comprehensive risk review. The best thing you can do is to get somebody else to check your own work. That is by far going to work way better than any process where you check your own work, because fundamentally checking your own work is actually quite hard. But really, you just want to come away from this step with confidence that your estimate is correct and aligns with the project scope. Now, the final step, and by far one of the most important, is to actually qualify your quote or your price into some sort of letter of offer. Now, you may have exactly priced what your client wants, although 99% of the time you're going to have some sort of qualifications, whether they've told you something that's wrong, they've given you incorrect information, or you've relied on things that they've told you not to rely on. For example, every client will send you a bill of quantities and put a general note somewhere saying you can't rely on our quantities. In that case, I would just say we've relied on your quantities in the letter of offer. But I'm kind of rambling. The purpose of step 6 is to submit your bid and provide the first step to then negotiate and form a contract value. This is where you're entering your price, you're providing your pricing schedule, you're clearly detailing what's included in your quote and what is excluded from your price. This is really an essential risk management step. It's qualifying your scope and basically linking your price to your terms and conditions. Now, I'm going to say I've described these steps as a sequential process. Realistically, they're going to be iterative. You might get halfway through calculating your direct costs and then picked up that your client has given you incorrect information, or you need to go back and raise an RFI, which changes the bid documents or how you've priced, or you need to add something to your pricing schedule. Look, I can't describe exactly what's going to happen. Every tender is different, but this is the core process to follow. It is going to be super iterative though. You're going to be going back and changing things. But really, by the end of this process, you've prepared a price that's linked to your terms and conditions that is going to be the basis for your commercial negotiations and how you effectively get to a signed contract for a profitable project. Are you using the best estimating method for your project, or are you putting too much effort into budget prices that don't matter and not enough into lump sum contract prices that could sink your business? There's 3 different ways to estimate: top down, parametric, and bottom up. They vary based on the amount of work required and the accuracy of the estimate. And as you can probably guess, more work means a more accurate price. By the end of this video, you're going to understand the different methods, how they work, and when to use them. An estimate fundamentally has 3 outputs: the price we calculate, the variability or accuracy of the price, which is often referred to as the class of the estimate, and importantly, the thing everybody ignores is the terms and conditions that surround that price. When we say terms and conditions, we mean the scope of works with price, the contract terms, the inclusions, the exclusions, basically the project specifications, what we have been asked to price. This is essential to understand. If you change the terms and conditions, you change the price. Now, these 3 elements combine to determine how we use an estimate. Early stage feasibility will calculate a price, but it will have a lot of variability and loosely defined terms and conditions. When we're talking about a contract commitment, we've got a fixed price. We want a small amount of variability because we've probably only got a 10% margin on that. Then we want clearly defined terms and conditions that match this. Different stages and decisions along the way require different forms of estimates. We're always going to come up with a price, but it's really how much variability and how clearly defined the terms and conditions are. Earlier on in the project, we're going to have more variability, looser terms and conditions. Later on, we're going to have a fixed price with low variability. Different stages require different forms of estimates, and the method we choose should balance speed, accuracy, and available data. We don't want to waste a lot of time preparing budget prices that are never going to amount to anything just to keep our clients happy. But on the other hand, if we're signing a contract, we want to be 1,000% sure that the price we're giving, the terms and conditions that surround that, are 100% accurate. Okay, so I've mapped out the 3 different estimating methods on this continuum. One end, we've got a low effort estimate where we've got low information. It's going to be inaccurate. The other end of the continuum, we've got lots of effort, highly accurate, which we're going to require a lot of information to put together. So a top-down estimating approach is where we estimate costs based on previous similar projects. This is the least effort, doesn't require much information, but it's also going to have a lot of variability. We've then got parametric estimating, where we estimate the costs based on historical rates and quantities, but we don't break things down into a lot of detail. And we've got bottom-up price, where we individually calculate every resource required to deliver the project, which is what we should be doing before we sign a contract. Okay, so top-down estimating is also referred to as analogous estimate. Basically, what this is, it's not really actually used that much in practice like this because it's so inaccurate, but all we'd say is if previously a bridge had cost us $5 million to build, we're getting asked to build another bridge, we're going to assume that's also going to cost $5 million. All we're doing is finding a comparable project where we know how much it actually costs to do, and we're adjusting roughly for inflation, size, or major scope differences. Again, it's the fastest method. It's minimal data required. We don't even really need to understand the project we're pricing in that much detail. So it's only used in early stage feasibility or concept design. While it's low effort, it's obviously very low accuracy because it assumes projects are directly comparable, which is never true. No 2 projects are ever the same. That's the definition of a project. It doesn't capture site conditions, design complexity, market factors. Basically, anything specific to the project will not be captured. It will only work if 2 projects are identical, which again is never true. So really, you'd only use this for very early stage planning, or if you're looking at your portfolio or pipeline. Say, for example, you know a certain project's coming up in a year or 2, and you want to map out your potential forecast revenue. That is really the only reason you would ever use this. Now, the next form of estimating is parametric estimate. What we're doing is we're taking the same principle behind a top-down or analogous estimate, but we're adding some detail by adjusting for a key quantity. The easiest example of this is, say we've built a 5 megawatt solar farm for $10 million. Roughly, from this, we know it costs us $2 million per megawatt we're installing. Say we're being asked to quote another project, which is 10 megawatts, so twice the size. We adjust by the key parameter, which is the megawatts of the solar farm, to get $20 million. What we're doing here is we're using statistical or mathematical relationships between key projects, variables, and cost. We know that the key driver of the cost of this project is the size of the solar farm in megawatts, so we're using that to determine the forecast cost of another project. To do this, it's very simple. We need to identify the key cost driver for the project. For example, if it's a solar farm, it'll be megawatts, but it might be the length of roads or the number of units of a building. We use historical data to develop a cost per unit. So for example, in this example, $2 million per megawatt, we multiplied by the new quantities to generate the estimate. Now, parametric estimating like this is fine, but again, it's very reliant on project A being almost identical except for the size to project B. There's another way I like to do this, which I'll refer to as enhanced parametric estimate, which is basically you just take the project, break it down into the component bits of scope, but very high level, then you use those to adjust the price. Yes. Now, you need a little bit more data to do this because you need to understand basically the key scope and the key quantities surrounding that scope. So for example, our solar farm, we can really break down in a bit more detail. We've got the length of access roads. We've got the number of solar panels, which is going to be driven by the megawatts. Maybe we've got linear meters of cabling, and we know whether or not we've got a substation, number of inverters or whatever. Basically, you break it down into each of those items, and then you come up with a cost per unit for access roads, solar panels, cabling, substation, whatever. This is just going to add a lot more detail. But again, if you're doing a road project, you might break it down into, I don't know, the length of the road, the volume of earthworks, the area of asphalt. Maybe you've got guardrail, maybe you don't. Maybe 5 to 10 components of the scope. You get the quantity of each, and you use a more applicable cost rate for that. That's going to adjust for any specific changes in scope not captured by the key variables. So this enhanced parametric estimating, I think, is a much more accurate way of doing it. And you can actually come up with quite an accurate price doing this. So parametric estimating, you balance speed and accuracy. It's easier to update as scope changes. You just change the inputs. You can remove access roads if you don't have access roads or whatever. It's good for early design and budget estimates, and it's also really good for checking your bottom-up estimates, which I'll talk about in a second. However, negatives of this, it does require reliable, structured historical data. Again, if you're using a rate per meter of access road, the cost data for the access road doesn't match your current project. It's not going to be accurate. It assumes a consistent relationship between cost and parameter. So for example, again, solar farm, there are some fixed costs associated with a solar farm. It doesn't necessarily scale exactly per megawatt. So it's not really going to cover any of these fixed costs and misses any unique site or special conditions. You can use it at feasibility and design development stage when you don't have enough data, like full drawings and specifications, and also you can use it to check bottom-up estimates. Okay, the final type we'll talk about are bottom-up estimates. So these are detailed estimates put together from the ground up. Every activity is costed. The labor, plant, materials, and subcontract. We know exactly what we're going to spend to deliver this portion of the project. We need to understand the work in detail. We need perfect drawings, perfect information to do this, because basically we have to work out exactly how we're going to deliver the project. How do we do this? We break the project scope down into a set of work packages or activities. We estimate the resources for each of these. So we need to know the labor, plant, material, and subcontract costs associated with that specific task. We sum them up to get total project costs, and we add in our project overheads, risk, and margin. All right, I'll quickly show you an example of a bottom-up estimate in my construction estimating and contract management software, Opera. So if you open it, you can see there's a sample project in here. From here, you can see, go into the estimate tab, you'll be able to see an example of a bottom-up estimate built in Opera. All this is a combination of, we've got a pricing schedule, or we've broken down the project scope into all of the tasks. So this is a commercial building project. We've got preliminaries, earthworks, concrete, building structure, services, finishes and fit out, and external works under these set of tasks. So this is our pricing schedule or our project work breakdown structure. Also got 2 indirect costs. So indirect costs are costs we don't want to show necessarily to our client, but we want to include them in our price. So all these are spread across our direct costs. And then within each of these individual costs, we've got a pricing worksheet, which shows how that cost was calculated. So for example, this is the suspended slabs of the structure. Within this, we've got our quantities of work. So how much work we've got to do. So 2,500 meters cubed of concrete, and we've got 1,200 meters squared of formwork. We've got to go through the drawings, measure these to calculate them. We've then got the combination of the labor, plant, and materials we use to complete that task. So for example, actually go into this one because it's a bit better. We need to purchase the formwork. So we need to allow for formwork supply and material. We need to allow for consumables and material. Then we need to allow for the labor to assemble formwork, which is going to be a combination of the quantity of formwork we need multiplied by production rate. We've got to do the steel fixing, which is going to be a combination of the total amount of tonnage of steel we've got to install, plus the labor to install it and the materials. And concrete is going to be a combination of a plant rate, which is a concrete pump to place the plant, the labor to actually place the concrete, and then the material to supply the concrete. So it's an example of a self-performed task. If we're talking about a subcontract price, we'd have to get quotes from vendors. For example, the installation of the structural steel. We've got 500 tons at $6,500 per ton. That would be a rate provided by a subcontractor and some allowance for consumables. So when you start to get a big estimate like this, each of these individual pricing workbooks where you calculate the price does start to take a little bit more time. It is a lot more effort. So if we're talking about the pros of the bottom-up estimate, it is what you should be doing to sign a lump sum subcontract or price. If you're signing a contract, you should have a bottom-up estimate. You shouldn't be relying on a parametric estimate. It's going to reflect the actual project conditions and construction methodologies, and it needs to be able to be traced and justified line by line. But again, if you're underquoting jobs, if you're making mistakes, then it's going to cost you in the long run. Now, the cons of a bottom-up estimate is obviously time-consuming and data-intensive. It requires detailed design and experienced estimators, and it's easy to make errors if scope or assumptions are unclear. So you use this method when you're tendering, planning execution, and also cost control during the project when you have detailed design and scope available. Now, in reality, what happens is we're going to use a combination of these methodologies. We're going to use basically everything from top-down to parametric to bottom-up in practice. So in real projects, early stage, we'll use top-down or parametric to come up with our budget pricing or get an understanding of the total project cost. Then when we're getting more information, we're actually going to sign a contract. We'll do a detailed bottom-up build-up. The thing I really like to do is your bottom-up price should roughly match your parametric estimate. And if it doesn't, you need to understand why. Maybe the input data or the rates you've got from historical projects aren't accurate. You really need to understand why they're not the same. So just to briefly summarize, top-down estimates are low effort, low accuracy, but only require a description of the project and past projects. So it should be used in feasibility and early stage planning. Parametric estimate, again, medium effort, medium accuracy. All you need is the key quantities, maybe some simple layout drawings, historical cost data. It's good for concept and budget estimating. And bottom-up pricing is when you get the full drawings, the specs, quantity takeoffs, production rates, quotes, everything. And then you do this when you're getting ready to sign a lump sum subcontract. Contractors underquote construction projects when they don't understand costs. Everyone budgets for labor and machinery, but what about accruing annual leave or factoring in sick days and understanding how your indirect costs are driven by the schedule? So in this video, I'm going to explain the different categories of construction costs that you need to understand to estimate accurately and manage budgets properly. The costs we incur to deliver a construction project can be broken down into some very simple categories. We've got our direct costs, the costs of physically doing the construction work, which will be made up of labor, plant, material, and subcontract costs. We then got our indirect costs, which are the costs of supervising, managing, and facilitating the works. These can be broken into recurring costs that are driven by the duration of the project and non-recurring one-off costs. Combine our direct and our indirect, we get our total project cost, to which we need to apply our margin, both our profit margin and our corporate overheads, plus factoring in the uncertainty that matters to our risk and opportunity to get our sell price, which is what we charge the client. So in this rest of this video, I'm going to talk about all these different categories of costs and what should be factored in and included in each of these buckets. But before I do this, I want to start with this idea of blurred lines. Different companies, different projects, different individuals have preferences for how to categorize these costs. So I'm going to talk about the general principles and what I think should be included in each bucket. But the reality is there are different opinions and there are different ways to do this. For example, traffic management, you could cover that as an indirect cost because it's not directly related to a specific construction activity, or you could include it in your direct cost budget. Subcontractor labor hire, you could call a subcontract cost or you could call a labor cost. A site supervisor might be categorized as a direct cost, might be categorized as an indirect cost. Different companies deal with upfront equipment purchases differently. They might charge the whole lot to the project, or they might choose to accrue it. Or temporary works, for example, might be included in the activity cost or the indirect cost. Now, there is no right, there is no wrong answer. The goal of categorizing costs and having these buckets is to come up with a comprehensive way to include accurately all the costs we incur to deliver the project, because missed costs equal missed margin. So going through this video, the goal is to understand these buckets and understand all the costs we are going to incur so you can estimate for them and track them properly. The goal isn't to memorize these categories perfectly because a lot of it comes down to opinion and project specifics. Okay, so the first bucket we're going to look at are our direct costs. Direct costs are the cost of physically completing the construction work. For example, if we're doing concreting, it's the cost of the concrete and steel reinforcement, the formwork labors, purchasing the formwork materials, and direct costs we can break down into labor, plant, materials, and subcontract costs. I like to think of direct costs as costs that directly contribute to the finished product the client's receiving. So the first of these buckets, we've got our labor costs. This is the site workforce that is physically completing the project. These costs include the base wages, superannuation, pension contributions, payroll tax, workers' compensation insurance, annual leave accruals, sick leave accruals, public holiday entitlements, long service leave, the upfront hiring and HR costs of finding people, and maybe any travel or accommodation costs related to the works. Now, I refer to these as on costs on top of their base wages. Some companies refer to it as the labor burden. And the point is you need to understand both the base wages and what labor burden or on costing you have. For example, you might have a carpenter that is receiving as their payment $45 an hour, but as a company, it's costing you $62 an hour once you factor in all these things. Now, our total labor cost is going to be a function of the hourly labor rate, the base wages, the on-costing and labor burden, the task productivity we've got, so the units of work per period of time, so how much work they're getting in how long they're doing the work for, the total quantity or volume of work. For example, 1,000 meters squared of formwork is going to cost more than 500 meters squared of formwork. And importantly, another very important thing to consider when you're talking about labor costs is non-productive time. So you've got your productive time, which is when you're actually doing the work. Then you also need to pay people for pre-start in the morning, any toolbox you're doing, paid lunch or smoko breaks. And my philosophy with labor costs is you want to track here any costs that are proportional to the total hours worked. So I would include subcontractor labor hire. I would call that a labor cost because to me, while you're not factoring in the base wages and on costing, you're just paying a fixed cost per unit of time. It's still proportional to the total number of hours worked. Next, we've got our plant and equipment costs. Now, plant and equipment costs are machinery and tools that we hire or purchase to do the construction activity. So they can be both owned plant and equipment, and these can be hired plant and equipment. These things be like excavators, cranes, or concrete pumps when we're talking about plants, or hand tools and power tools when we're talking about equipment, scaffolding, site vehicles, so on and so forth. When we're talking about these rates, we want to get an all-encompassing total cost of using the plant and equipment. The same way when we spoke about labor, we spoke about payroll tax, superannuation, public holidays, sick leave entitlements. When we're talking about plant and equipment, we need to factor in all the additional costs on top of the actual cost of hiring the plant. So this might be things like fuel and maintenance, floating the equipment in, floating it out, or if we own the equipment, any financing and capital costs. Now, in addition to that, if we are hiring plant or equipment or a subcontract, they might give us a wet hire rate, which means that the operator for the equipment is included in the rate for the plant. This is typical when we're talking about things like crane hire. The total cost of plant for a project is going to be a combination of the plant rate, so whether that's an owned rate that we've built up from depreciation and financing costs, or whether that is a daily or hourly hire rate plus any fuel and servicing. Then we've got any regular fixed costs, which might be servicing, floating the equipment in or out or whatever. Then same with labor, we've got our task productivity, which is going to be a function of units of work across time. Now, one thing with plant that you don't get as much with when you're estimating labor costs is that plant is often hired for a fixed duration, plant and equipment. So you might only use scaffold for certain periods of time, but you are going to hire the scaffold at the start of the job and off hire it at the end of the job. So sometimes productivity isn't a good metric when talking about plant. You have to talk about fixed duration and do what's referred to as a plant balancing, where you can work out how much plant you need across the duration of the project and then smooth that out. And then as well, if we are talking about production rates, it is going to be a function of the total volume of work. Same with labor is we're going to have this non-productive time factor depending on how much the plant's actually used. This might also be, you can also have overutilization of plant where, for example, you're paying a daily rate for an excavator, but if you're also doing a day shift and a night shift, you're actually not getting charged anything extra for the hire during the night shift, which would reduce the plant rate. So plant, more so than labor, you have to understand the utilization of the plant to price the works properly. So under plants, I would include any costs that are driven by the duration of the task or the duration of the project. So for example, I wouldn't include temporary works materials as plant and equipment. I would include those as a material cost because it's a one-off upfront purchase, but I do know some people like to include these things as plant and equipment. Next up, we've got our subcontract costs. So these are the costs of any specialist trades engaged to complete specific scope of work. So if we're a general contractor, the majority of our project direct costs are going to be made up of subcontractors. So you've got things like electrical, plumbing, HVAC, painting, civils, so on and so forth. We can engage these subcontractors under different contract models. So we might get a lump sum quote, so a quote to do the entire package of works. They're taking the risk for everything. We might get a schedule of rates quote. For example, we want someone to come in and do trenching, but we don't know the exact volume of trenching. So we want a rate per meter to be adjusted by the actual quantity. We can have cost reimbursable contracts where we're paying a subcontractor for the value of the work they've completed. So they'll charge us for the materials, the plant and equipment they're using, the labor. Now, as I said, if we're doing cost reimbursable works, I would include all these costs under the labor, plant, and materials buckets. I wouldn't think of them as a subcontract cost, or we can get them under wet hire. For example, hiring a crane with an operator, but again, I would consider that a plant cost, not a subcontract cost. When we're getting subcontract quotes, what we have to understand is that what we're asking them to do drives the cost. Sounds very simple, but people don't necessarily think of it that clearly. If we're asking people to do certain things, it's going to have a certain price tag associated with it. So when we're talking about subcontractor costs, the key thing to think about is the scope of work and the specific inclusions and exclusions. Now, the natural extension of this is if we change the work, we change the scope that someone's doing, they're going to hit us up with a bill, which is where we enter the world of variations, everyone's favorite topic in construction. But it's why it's such a big deal because, yeah, this is going to be a bit of a side, but construction, as we all know, is messy and complicated. So actually nailing down the specific inclusions and exclusions, which is what is driving the price of the subcontracted works, is very, very difficult. And so it's why construction just inherently involves so much change and so many variations. So when we're talking about the total cost of subcontracted works, that's going to depend on the scope of works, what we're asking someone to price, the level of competition and number of quotes we get. If we're getting a specialist trade contractor, there's only one person who can do it in the entire market we're getting quotes for, we're going to end up getting a higher price. But if we can go to 20 subcontractors, I'm not saying you should get 20 quotes, but in theory, something like concreting, where there's a lot of contractors that do it, will often get much better pricing if we introduce competition by getting more quotes. Then how well we define the scope, what variations we incurred during construction. We also need to factor these in. Then any costs we incur to manage the works, while we wouldn't include them as a subcontract cost, we still need to think about and consider them in terms of the overall project costs. Now, again, when we're talking about cost reimbursable contracts or wet hire, I don't consider them subcontract costs. My rule of thumb for what is a subcontract cost is something where another company is taking risk on that item, meaning they're taking the responsibility to do the work and they're quoting to do it either through a lump sum contract or a schedule of rates contract. So the final bucket of costs we've got that I haven't included a lot of information for because they're actually relatively simple and straightforward, but they do form a huge portion of the project budget, is the physical materials that are going to be incorporated into work. So these are things like concrete, steel, formwork, fixtures, so on and so forth. Now, within materials, I also include any temporary materials that we purchase and consume in the project. So formwork, a temporary material, I would include here, but I wouldn't include scaffold because it's not something we're actually consuming through the works. When we consider material costs, we need to think about the delivery costs, the costs of getting those materials to site. Again, certain types of projects, the logistics of actually getting the materials to site, for example, a remote construction project in Australia, can be a huge portion of the overall project cost. We need to consider wastage allowances. So if we're factoring in 5 to 10% of the material being wasted for consumable items. And we also need to factor in storage, handling equipment, and also any completions requirements we have where we may have to hand over spare parts. Okay, so where are we up to? We've gone through our direct costs. We're talking about labor, plant, materials, and subcontract costs. And I also would like to more or less draw into distinction that these three items I would refer to as self-performing costs where we're managing the works ourselves. Subcontract costs when we're engaging another company to do them. However, together, we've come up with our direct costs, which are the cost of doing the physical construction works. Next, we're going to talk about indirect costs, which are the cost of supervising, managing, and facilitating the works. So, indirect costs are the cost to facilitate the works not attributable to a specific activity. One way you can think of them is that they're not part of the finished product the client is paying for. But again, if I go back to that example of traffic management I spoke about at the start, sometimes that doesn't really work because some people would consider traffic management a direct cost related to a specific task. But again, this goes back to the blurred lines. There is some overlap and confusion between direct and indirect costs. That's why you just have to understand all the different costs and categorize them in a way that best suits your projects. But typically when we're talking about indirect costs, we're talking about things like staff salaries, temporary offices, permits and approvals, a laydown area. These are costs that are going to be attributable to many different construction activities. So we've referred to them as an indirect cost. Now, I probably need to do a little more thinking and explanation of this, but another way I use the term direct and indirect costs, and I don't want to add confusion with this, but when you're preparing an estimate and submitting it to your client, I use the term direct cost as an item that we're going to show to our client in the pricing schedule, that we're going to put a sell price against, and an indirect cost, something like insurances or inclement weather, which we don't want to show in our pricing schedule to the client. So we're not going to mark it up and produce a sell price. But any money we put against these items, we're going to spread across all of our direct costs. Now, I do need to come up with better terms from that, but that is another, and I don't want to add confusion, but that is another way of thinking about direct and indirect costs. Again, there's going to be tons of overlap and it's project specific. It comes down to personal preference between direct and indirect. And at the end of the day, it's not an important distinction as long as you understand that all the costs you're going to incur to deliver the works are budgeted for somewhere. Now, indirect costs, we've got two main categories. We've got non-recurring one-off costs like setting up our site facilities, paying for permits, paying for bank guarantees at the start of the project. Then we've got our recurring costs, which are driven by the duration of the project. That is why time is such a big driver of cost. Think about this. If you have a construction project and you need a full-time project manager, if it's a 6-month project or if it's a 12-month project or if it's an 18-month project, we're proportionately increasing the cost of project management. 6 months to a 12-month, we've doubled the cost that we need a project manager. We can apply that to hiring offices, toilets, staff salaries, all these things, and we can understand that the duration of the project is one of the key determinants of indirect costs. Okay, so where are we up to? We have built up our direct and indirect costs. What we need to now do is convert our total project costs into a sell price by adding on our risk and opportunity, allowing for the uncertainty that matters, our corporate overheads, and our profit margin. Okay, so the first of these is going to be our risk and opportunity. So an estimate is an estimate. When we're predicting how much a project's going to cost, we're taking all of our input information, rates, subcontractor pricing, productivity rates, our planned methodology, what we think is going to happen. We're putting all of that together, coming up with an idea of how much it's going to cost to deliver the project. But there are things we don't know, and there are things that are impossible to know at the outset of the project. We don't know how much it's going to rate. We don't know what those exact productivity rates are going to be, the exact ground conditions, if there's going to be design changes, or if our clients missed a whole lot of scope and going to give us a whole lot of profitable variations. Risk in opportunity is the process through which we allow for uncertainty in our price. Now, this doesn't necessarily just mean adding on contingency and contingency. Risk can also be positive, which is what we refer to as an opportunity. So if it's bad, we think of it as a threat. If it's got upside, it's an opportunity. We can allow for this uncertainty in our price generally two different ways. So we can just have broad project contingency, for example, marking up the entire cost by 2%, or we can do an activity-specific build-up where we look at every possible risk and opportunity and associate a probability and an impact against this. Now, the second method of doing a risk and opportunity build-up, what that isn't going to factor in is the unknowns and unknowns, the things we couldn't even possibly predict were going to happen. So we are always going to need some amount of percentage-based overall contingency. Whether we call that a risk and opportunity or whether that's factored into the profit margin we have on the project is another issue, but there is always going to need to be some allowance for unknown unknowns. Now, if we're going to do an activity-specific risk and opportunity register, we need to build up a complete superset of what could possibly go wrong. Against that, we apply a probability of how uncertain that event is, the impact, what will happen if that occurs. Then we can get the value of that level of uncertainty, which is the probability multiplied by the impact. Then we need to come up with a mitigation, or when we're talking about an opportunity, some way to increase the likelihood or probability that it occurs. There will be some sort of mitigation cost, so the cost of implementing this mitigation, and then there will also be a post-mitigation probability and impact. So once we've done the mitigation, we've reduced the probability, reduced the impact, we'll have some sort of mitigated value. The next thing we need to factor in are corporate overhead. So in the same way, an indirect cost relates to a direct cost, not attributable to the specific activity. Our corporate overheads are business running costs that are non-specific to the project. So these are things like our head office rent and staff, our company vehicles, software costs, accounting and legal, insurances, IT systems, and probably the biggest one for construction companies is your marketing and business development, which is your cost of tendering new work. Now, the standard way of doing this is having a percentage across all of your projects, but again, some contractors will just bake this all into their profit margin. The way you work out what your corporate overheads markup should be is you need to have a forecast revenue amount. So say you're going to do $10 million of work this year, and your cost, your head office staff, all these things, tendering work is $1 million, then basically you need to allow 10% on every project to recover that $1 million. Now, the final thing we need to include on our costs is our profit margin, which is the bit we care about. That's what's left over for the owners of the business after all these costs have been paid. With our profit margin, you can either reinvest this, so you can buy better equipment, grow the business, hire more staff, do things like that, or it can be redistributed to the owners of the business. Profit margins are a function of our project risk. So generally, if we're doing a riskier project, and that's when I was mentioning before about how you include contingency, is that the general approach is the more risk you're taking on as a contractor, you should be rewarded with a higher profit margin. If you're doing a cost reimbursable project where you're taking on zero risk, you're probably happy to do it for a lower profit margin. If you're taking on some huge EPC challenging project that there's a real risk of things going wrong, you probably want to be compensated with a higher profit margin. Top of that, the other factor that's going to influence profit margin is the market competition. So how many other contractors are out there who can do the exact same work that you're going to be competing against? If there's not many, you can charge a higher price. If there's a lot, you've got to charge a lower price. And then also the relationship you've got with your client. If your client loves you and wants you to do the work, they're probably happy to pay a slight premium to work with you. If you have no relationship with the client, they just see you as contractor A, B, or C, then you obviously don't have the opportunity to increase your profit margin because you're going to be winning the project based on price. So basically that is how we went. So I'll just scroll back up to the top quickly. That is how we went from our direct costs, our labor, plant, materials, and subcontract, our indirect costs, our recurring and non-recurring, non-activity specific costs together. With our total costs, we've applied our margin and risk and opportunity, and we have a price to bill the client. So those are the categories of costs. Again, this wasn't an estimating video of how you calculate these costs. This was purely talking about what these buckets are so you properly understand them. Now, I want to show you some broad industry-based figures so you can understand which of these costs actually matter. Now, I saw these numbers. I did some research to find them. I'm a tiny bit skeptical about some of them because the numbers I've seen on projects tend to be quite different, but I guess these are probably more broad general industry numbers, and I've tended to work on larger projects. So I've seen often overheads have been much higher than what you're seeing on these, and profit margins tend to be a little higher. But these are typical breakdowns of project costs. Instantly, what stands out to me, and I think what is relatively obvious, the bulk of your costs are labor and materials. Equipment, not a huge cost. Overheads, these I thought were a bit smaller. I'm used to seeing overheads as a higher proportion of the overall project cost. But when you're thinking about the cost to drive a construction project, and I guess everyone probably knew this intuitively, purchasing materials and the labor, they are the big drivers of cost and what you really need to understand. So as I said in the beginning, this wasn't a video about the estimating process. This was a video about construction costs and understanding all the different categories of costs and how they fit together. Again, it's not meant to be prescriptive, saying exactly where each item of cost goes. It's meant to be comprehensive. Because at the end of the day, if you miss factoring in any of these items into your estimate, or you're not tracking and controlling them properly, missed costs equal missed margin. 69% construction projects miss their budgets by more than 10%. Studies show the material and labor costs, i.e. the direct costs of a construction project, account for 60 to 70% of these cost blowouts. To avoid this, there's a simple 4-step process we can follow to putting together direct costs of a construction project to avoid this happening. In this video, I'm going to walk you through this exact 4-step process to accurately calculate the direct costs of completing a construction project. This is all our labor, plant, material, and subcontract costs. Importantly, I'm not going to be talking about indirect or overhead costs. This video is all about physical construction costs. So the first step in this process is to set up our estimate. We're going to create the structure of what we're going to use to prepare, present, and defend your price. Now, fundamental principle behind this, if you're familiar with it from project management, is creating a work breakdown structure, which is just a structured breakdown of the project scope. Basically, we're going to list out all the individual tasks that we need to price. We're going to structure it in a way where we present it to our client. Now, this schedule will either be provided by the client as part of the tender package, or we will be creating it. This is such a critical step to get right because the pricing schedule is the framework for the entire estimate. Basically, how we're going to put together our entire price. It needs to be logical, so it needs to be a structured breakdown of the project scope that makes sense, where we're breaking down things comprehensively so every single individual task is covered. Next, we want to make sure it's easy for the client to understand. It shouldn't be confusing. It should be a very transparent way of presenting our pricing that explicitly shows what's included and excluded from the price. For example, if we're pricing concrete works and we're not including in our price the supply of the permanent materials like concrete and reinforcement, we should say that in our pricing schedule. We should say concrete structure XYZ excluding permanent materials. And Because at the end of the day, when we submit this quote, this is going to be a reliable reference during negotiations and construction. If we get into a dispute about what's in or out of scope, we're going to go back to the pricing schedule and we're going to show them how we presented our price. Now, it might contradict the scope of works, but again, if our pricing schedule is explicitly stating all this stuff, it's harder for them to push back against us. Pricing schedule should explicitly spell out all of our key activity descriptions, any key assumptions, and the units and quantities of each task. So this is an example pricing schedule from my construction software, Operum, that shows the project scope broken down into earthworks, concrete works, the building structure, the services, the finishes and fit out, and the external works. Against each of these items, we've got a quantity of work, a unit, and a rate we've calculated through the estimating process. So crystal clear, see from this scope exactly how we've priced the project. We've priced 5,000 meters cubed of earthworks, 2,000 meters cubed of placement, the foundations are 1,000 meters cubed. Now, again, this may contradict the scope of works, but if they've given us quantities, if they've given us information to rely on, it should be in the pricing schedule. For example, we say concrete placement only immediately shows we're not supplying concrete, or if we're being asked to do 2,000 meters cubed of earthworks, but in our pricing schedule, in the information we relied on, that is the scope we're doing. If they're saying we now have to do 5,000 meters cubed, then that's a contradiction from the information. Basically, strong pricing schedule prevents misunderstandings, reduces the chance of disputes with our clients, and makes everything downstream much, much easier. It also gives us an easy way to break down the project scope so we don't miss anything ourselves. Now, I should just mention, within the pricing schedule, you'll have your direct costs. So these are the things you want to show the client, and our indirect costs. So these are the things which we need to include in our overall costs, but we don't want to show them as line items in our schedule. All right, so the next step in this process is we need to establish our methodology. We've broken down the scope when we set up our pricing schedule. The next thing we need to do is we need to determine how we are going to deliver each of these portions of the work. So when I'm talking about methodology, really what I'm talking about is how we're doing the work, but more specifically, how we're going to deliver the project scope. I always think of this as a continuum between self-performing the work, where we engage all the labor directly, we purchase all the materials, hire the plant, and manage it ourselves, in which case it's the lowest cost because we're not paying margins for subcontractors, but it's going to be the most effort to manage because we have to coordinate and manage everything. It's also the most risk for us because we're exposed to production rates, delays with materials, all these things. Then we've got a range of hybrid options such as wet hire, free issuing the materials to subcontractors, or using a schedule of rates. Then at the other end of this, we've got a lump sum subcontract where we fully outsource the scope of works to a subcontractor. Now, this is a continuum, but the fundamental way we price something will be different if it's a self-performed task versus if it's a subcontract task. Really, they're two different estimating workflows, but really, key here is for every task in our project scope, we want to understand exactly how we're planning on delivering the work. Are we planning on subcontracting it? Are we going to use a combination of self-perform and wet hiring a crane? Or are we going to get some sort of schedule of rates contract? Really need to get into the nitty-gritty, understand exactly how we're doing the work. So if we're self-performing the works, we need to fully understand the construction methodology, exactly what materials we need, what sort of consumables, what plant we need to hire, exactly what mix of labor and crew composition. We need to know the exact step-by-step sequence, the labor mix, the productivity, the material requirements, and we're pricing the work from first principles. If we're subcontracting the work, it's fundamentally much easier to price because all we're doing is we're putting together a scope of works and a set of drawings. We're showing to our subcontractor what we want them to do, and we're running a competitive tender, getting 3 to 5 quotes for the work, comparing, analyzing these quotes, covering any gaps, and then including this pricing in our estimate. So subcontractor pricing is much, much easier, but again, with less effort is going to come a higher cost because we need to pay profit margins of subcontractors to do the work. I should also state for clarity that sometimes subcontracting is actually cheaper than self-performing the work because sometimes you get subcontractors who just have better productivities, can do the work better, actually get better labor rates than we would do. So really, it's not as simple as subcontracting is always higher cost. You really need to analyze all of these different options and come up with the best methodology. That's why I really think methodology is where you can make or break your estimate. Okay, so far we've broken down the project scope into a pricing schedule that's comprehensive and logical and covers everything we're pricing, and we've come up with our methodology. For each of these tasks in our schedule, we know exactly how we're going to deliver it. Next step is our quantity takeoff. At the end of the day, quantities drive cost. It's an obvious thing to say, but doing 500 meters squared of formwork is going to cost more than doing 200. Now, there's really steps 3 and 4 you can sort of do in parallel. Depends a bit on how you like to estimate. Some people like to sit down at the start of the project, a set of drawings, and just measure every single quantity. I prefer to do my quantities in parallel with doing my resource buildups because it makes more sense to me when I'm looking at a task, understanding how to do it, but I measure the quantities I need to know. The reason I find this the easier way to do it is because you don't necessarily know exactly what quantity you need to measure until you start pricing the work. For example, even if you're measuring formwork, you might have a different production rate for a slab versus a wall. So you just go ahead and measure all the formwork. You haven't broken it down into different types of formwork. You might go back and redo your quantities. But at the end of the day, you just have to work out what works best for you. I always do steps 3 and 4 in parallel. Some people prefer just to sit down and do all the quantities at the start. Also, again, for subcontract works, for self-perform works, you're measuring quantities differently. For subcontract works, you really only need to know the key high-level quantities to create a pricing schedule for subcontractors. Again, we'll want to send our subcontractors some breakdown of the project scope with key quantities. That's the only thing we need a quantity for to help us compare price and manage the quotes that they send us. You don't need to do a full detailed takeoff with every single tiny thing. For example, for subcontract works, you might just measure 1,000 meters cubed of concrete. You don't need to measure exactly how much reinforcement, formwork, area of any barriers or surface protection. The subcontractor should be working all that out. For self-perform works, you're going to be responsible for measuring every single quantity in detail. For example, the concrete volume, formwork area, the tons of reinforcement, the surface area for curing any saw cutting lengths, consumables, waste factors, and so on. Every single quantity in detail needs to be measured. Now, the final step, again, I do steps 3 and 4 at the same time, but some people prefer to do them sequentially, is you then need to convert your methodology and quantities into dollars. This is where your direct costs are going to be calculated. You're building this up into 4 key categories: labor, plant, materials, and subcontract. Any single task is going to be some breakdown of this. If we go back to our continuum, if it's a full lump sum subcontract, then it's just going to be a subcontract cost. If it's a self-perform, it's going to be some breakdown of labor, plant, and materials. If it's a hybrid thing, like a wet hire of a crane or something, it's going to be a breakdown of labor, subcontract, materials, whatever. For subcontract works, again, this is going to be much simpler for full subcontract stuff because all you're doing is receiving and consolidating the quotes that you get from a subcontractor, comparing these and leveling them, clarifying exclusions and gaps, and choosing your preferred subcontractor. So if I quickly go into Opera, and again, you can use Opera for free. I'll put a link in the video description. But if I look at something like an earthworks package, our pricing schedule. So this is what we send to our subcontractor. We want them to include these items: demolition of existing structures, tree removal, bulk excavation, blah, blah, blah. We've got our list of subcontractors that we've gotten quotes for, and then all the different quotes we've got from our subcontractors. We then need to compare these and choose which of our subcontractor pricing we want to include in our estimate. It's important when you're doing this that we're reviewing the actual terms and conditions that they submit to us in their quote. So for example, this subcontractor provision civil, they didn't include rock excavation, so we put an allowance of 12.5 grand in there to cover that. This subcontractor, Melbourne Excavations, they didn't include wet weather allowance, so we put in there a provision for that. We can compare all their quotes and select the quote we want to include in our estimate. Really, subcontractor pricing is as much about paying attention to terms and conditions as it is about understanding the actual task specific. Now, for self-performed tasks, this is going to be much more effort because we're not just putting quotes into our estimate. We actually need to break down the task and look at it in detail. So we need to work out the labor and plant combination, referred to often as the gain rate for doing a task. For example, if we're doing trenching, we might have 2 laborers and an excavator and a truck to remove the spoil. Then we need to understand the production rate associated with the task. Are they going to get 50 meters a day? Or are they going to get 100 meters a day? Or is it a program-based task? So a program-based task is where you have a fixed duration task will take. For example, if you're installing girder beams on a bridge and the precast yard can only deliver you 4 per day, you're going to have a crane sitting there. Even if it could install them in 30 minutes, the crane and the workers are going to be sitting there for the entire day. So that's an example of a program-based task. So you need to understand whether it's production-based or program-based. If it's a production-based task, it's going to be as simple as taking the quantity of work we're doing divided by the production rate. So we've got to do 1,000 meters of trenching. We're doing 50 meters per day. We're going to have that same combination, that gain rate for 1,000 divided by 50. We're going to have that for 20 days of work. If it's a program, it's the same resources, but multiplied by a fixed duration. If it's going to take 2 weeks for the girders to get delivered, we're going to have a crane and the workers sitting there for 2 weeks. That covers labor and plant. Material is going to be a combination of the quantity we're ordering multiplied by the unit rate we're getting from the supplier, plus any wastage, delivery, whatever. And then we also need to think about per task, any sort of mobilization, demobilization, consumables. We repeat this for every line item in our pricing schedule. Okay, so if I quickly go back to the sample project in Opera, and I'll just pull up a worksheet to show you what this is like. So this fabrication and erection, this is just a subcontracted task where we're getting them to install 500 tons of steel. They're fabricating and installing it, and we're just they've given us a rate of $6,500 per ton. So that's where we get the $3 million. We're allowing from $5,000 of consumables. For a self-performed task, let's use concrete suspended slabs as an example. We've got our quantity of concrete, which is 2,500 meters cubed. We've got our quantity of formwork, which we would have measured from the drawings, which is 1,200 meters cubed. We've got our formwork supply rate, which is $100 per meter squared, multiplied by the area of formwork, which gives us $120,000. We've got our formwork consumables, which are $5 per meter squared, multiplied by that same quantity of formwork gives us $6,000. We've got our labor, which is 3,000 man hours, which is going to be the multiple of the formwork area multiplied by our production rate, which was 2.5 man hours per meter squared. We've also got the concrete material, which is 2,500 meters cubed. Now, this is really embarrassing because I just realized when I was doing this that I have the concrete supply, but I don't have the concrete install. So I need to go and fix this after I need to go and fix this sample project. But I go for another one. Hopefully this, oh no, this is the same one. Hopefully this one is a bit better and it shows, this one's better. So if I look at this sample project now, oh, I missed the reinforcement from the other one as well. That's embarrassing. Whatever. So here we've got the quantity of concrete and formwork. We've got the formwork supply, we've got the formwork consumables, we've got the labor to install the formwork. We've got the variable, which we stored in our library, the reinforcement ratio, which is 0.2 tons per meter squared. And then we've got a production rate of 8 man hours per ton multiplied by the tons of formwork to give us that. And we've also got the concrete install, which covers the pump, the labor for the concrete, and then the materials for the concrete. So all this pricing is just a combination of a resource we've got in our resource library. So for example, we can have a quantity, can have a variable like a reinforcement ratio. We can have productivity rates, for example, 10 meters cubed per hour for excavation, got materials, subcontractors, whatever. And then we basically, when we're building up our costs, we're just combining our resources with our quantities, very basic calculations. All it is year 8 maths. And that's all it is. We go through our entire pricing schedule, price every single individual item to come up with our cost. Very basic maths. The hard part is getting all the information together, populating our resource library, getting accurate rates for everything, accurate subcontract quotes, and also understanding the construction methodology. To me, the maths, whatever, is the easy part. Hard part about estimating is getting all this information together. Again, in this video, I don't talk about pricing overheads or project management or any of this stuff. This is just how you calculate the actual construction costs of doing the task. Labor is the #1 reason for construction cost blowouts. And it's simply because labor costs are very difficult to accurately calculate. Materials and subcontractors are easy. Measure what you need, get quotes, and input them into your estimate. Plant is usually a tiny portion of the project cost and is actually driven by labor. But labor costs, now you're dealing with HR agreements, measuring quantities, determining accurate productivity rates, working out non-productive time, and 100 other factors. Get any of these factors wrong and you'll either underquote and lose money on the project or overquote and not win it. So in this video, I'm going to show you exactly how to accurately estimate construction labor costs. We're going to go through rate buildups and accurately calculating cost recovery rates, determining non-productive times, production versus program-driven tasks, productivity-based estimates, and how to determine task productivity, and also a program-based labor estimate. I learned how important and difficult calculating labor costs were firsthand when working on a major oil and gas construction project. It was completely cost reimbursable, but we lost our profit margin if we overran the budget, so we still had to accurately come up with a cost to complete. The client was free issuing all the key materials, so the project costs were 80% driven by labor. So we had to set an accurate budget or we were going to be doing the project for free. But we made some major mistakes in our pricing. We didn't factor in travel time to site. We had to close the main car park to store materials, and because of this, we had to ferry workers from the offset car park to the existing car park, which ended up taking almost half an hour each way. Because the methodology was our risk, the client said that additional travel time should have been covered in our labor rates. On top of that, we had an error in our spreadsheet on a key production rate. So what we were charging per unit installed ended up being too low. And even though some major things went our way, we got some key variations, some increases in the quantity of work, we couldn't even recover the cost for the additional work because our labor rate was wrong and our production rate was wrong. And basically, we lost money on variations, which you should never do. This was the first time in my career I'd seen firsthand the compounding effect of labor buildups. Think about it. With every single labor rate, you have three dependent variables. You have the cost rate, the productivity rate, and the quantity of work. That's three different places that your labor estimate can go wrong. On top of that, often your pricing at tender will be used as the basis for any variations. Most of the variations you'll get will be largely driven by labor. So if your pricing at tender is bad, it's even more difficult to accurately get change orders approved with a healthy margin. So that's why labor isn't just the biggest cost on a construction project, it's also the one with the most uncertainty and risk associated with it, and why you need to do a very good job of calculating it properly. Okay, so how does calculating labor costs actually work? Well, surprise, surprise, it's a combination of two key things. The labor cost rate you come up with, the number of hours you need to budget for on your project, which gives you the total labor cost. Now, there's two ways this can be wrong. Well, theoretically three, if you factor in that the hours are a function of productivity and quantity. Really, you can either have the rate wrong or you can have the total hours wrong. The total hours being a combination of the task productivity and the quantity of work. Now, through this video and what I'm going to discuss, the goal is for you to understand the process, not to copy the numbers, because what happens with labor and what's so confusing about it is it's a function of so many different things that it's very easy to either double count, duplicate things, or miss items. So first off, let's talk about how to accurately come up with the labor rate, and then we'll go on to coming up with the total man hours. So the first part of this is all going to be about calculating the labor rate. The labor rate is what one person costs per productive hour. So what does someone working on a specific task cost the business per hour? That's what we need to recover in the labor rate. This is going to be a combination of the salary, the on-costing, and the ratio of the productive and the non-productive time. But as you see, it's a little bit more complicated than that. That's why it's so essential that you understand the process and where the numbers you're using are coming from, so you're not double counting things. Now, the salary is what someone is paid for an hour that they're at work. So if someone gets paid $50 an hour, their salary is $50 an hour. Salary is pretty easy to understand, but what they cost the business is different to their salary, because On top of this salary, for whatever they cost the business for 1 hour they do the work, we have to factor in annual leave, sick leave, public holidays, superannuation, payroll tax, allowances like PPE, consumables, as well as hiring and recruitment costs. So what this basically means is while someone gets paid $50 an hour, that's what goes into their bank account for 1 hour of work, what they really end up charging the business is probably more like 35 to 40% more than that. And this is referred to as the loaded cost rate of someone working. So for example, if we factor in, so this is an example from a spreadsheet. I'll put a link to you can download for free in the video description. If we factor in 8% for annual leave, which is 4 weeks of annual leave a year out of 52 weeks, public holidays, 2 weeks per year, which is 12%, sick leave, which is another 2 weeks per year, superannuation of 11%, workers' compensation of 4%, payroll tax of 6%, we actually end up with an on-cost percentage of 36%. So the other example I was using was 38. I should have made those numbers the same. We end up with the cost of that person is $69 per hour to the business. The true cost per hour on the project is significantly more than their salary because we've got to factor in all these additional costs. Now, you'll see in this calculation spreadsheet, this is based on 38 hours per week. So I should have mentioned before, I skipped over this bit. You also have to factor in the working week. So are they working purely normal time or are they doing a bit of overtime? How many overtime hours they're doing? Generally, I like to work out the salary per week, then just divide it by the number of hours they're working. So if they're working 38 hours, 40 hours, whatever your normal week is, it'll just be the base rate. But if they're working some overtime rates, I would calculate the overall salary per week. But if they're at work 60 hours a week, 38 hours, whatever, are they actually doing productive work that entire time? Well, the answer is no. They have pre-starts, toolbox talks, morning tea, lunch breaks. They have to walk to site, away from site. They have to pack up their equipment, get set up for tasks, move between tasks. All of these things impact the number of productive hours they work. Now, here's where things start to get a little bit confusing and why this part at the start, I really want to stress where it's understanding the process, not copying the numbers. But you need to understand when we talk about applying a productivity rate to this cost is some people will include in their productivity rate non-productive time. Some people won't include it. So there's two ways we can measure productivity for a task. We can use the stopwatch method, which is purely the task productivity. So it excludes breaks, meetings, setup, and waiting. Looks faster on paper, but you need to factor in non-productive time. So the stopwatch method is if someone's putting up form work, you stand there with a stopwatch and measure how long it takes them to put up a meter squared. If it takes 2 hours, that productivity is 2 man hours per meter squared, but it doesn't include any non-productive time. Now, the other way to measure productivity is you take the output of a crew or an individual per week, divide it by the total number of hours that they've worked per week. This is the method that makes way more sense to me and I think is way less error prone because it includes non-productive time in that. So the productivity rate includes non-productive time. So say a 4-person crew puts up 80 meters squared of form work. They each worked 40 hours per week. The production rate you would get is 2 man hours per meter squared, but this already has non-productive time baked into it. It's factoring in setting up, packing up, putting rubbish in the bin, lunch breaks, all that stuff. That's why I prefer, and it makes way more sense to me, that you do your productivity rates like this based on what a group of people get done in a week. You take the average of that, you'll come up with a more reasonable production rate with non-productive time already baked into it. Now, some people would criticize this method to say that different jobs have different non-productive times, and to a certain degree, that's correct, but usually lunch breaks, smoko breaks, all those things tend to be the same job to job with a little bit of variability. I think the stopwatch method is too specific and increases the risk that you undercook your productivities because you have to factor in every single step of the process, and all that's going to happen is you're going to miss things. So I think this method makes a lot more sense to me, and you're taking the average of a group of people. But if you do use the stopwatch method for your task, you'll need to adjust for or include non-productive time on this. So for example, if you work out that on an 8-hour workday, they're only on site being productive 6.5 hours per day. you can either adjust the productivity or adjust the rate to get a productive rate. So for this example, you could times the rate of $69, the on-costed loaded rate, by 8 on 6.5, which gives you $85 an hour, which is the rate you would need to apply to that productivity. However, again, if you're using the weekly crew output, you don't need to factor in non-productive time. So that's how we come up with our cost recovery rate. And I don't know if I made this too confusing. You just really have to understand how your productivity rates are calculated and what's baked into them. Because if you do double count non-productive time, you'll increase your price a lot. If you don't include it, you'll undercook your productivities. That's why, again, I prefer the weekly method. But the next question we need to answer is how many hours of work do we need to budget for on our project? And this is a very simple process. We build a work breakdown structure, take the project scope, break it down into tasks, decide whether a task is production-based or program-based. I'm going to explain these terms in a second. We then measure the quantity of work associated with each task and then apply a productivity rate or duration, depending on whether it's a production-based task or a program-based task. So the first step in this process is we need to create a project work breakdown structure. To do this, we want to break the overall project scope down into a series of tasks. And the only way we can do this is by deconstructing and understanding the scope and drawings. We filter by layer. So we take the project scope and we put it into a hierarchical decomposition. All this means, a fancy way of saying, we take the scope and we break it into smaller and smaller pieces until the level of detail I like to go to is each task should have one clear combination of labor, plant, materials, or subcontractors per task driven by a single productivity rate. So, for example, you could take a construction project, you could break it down into foundations, structure, fit out, external works, and landscaping. Then within foundations, you break it into the separate slabs. And then again, each slab, you have a combination of concrete works and productivities. This structure, the work breakdown structure, I think is one of the most important concepts in construction project management. And it is the structure we use to drive our estimates, our schedules, cost control, and our quality and procurement. So if I go through and show you a quick example from Operum, my estimating software, of what this would look like for a commercial construction project, this breakdown is the same breakdown we're going to be using for labor, plant, materials, whatever. But basically we've taken, this is a commercial construction project example. We've broken it down into earthworks, concrete, building structure, services, finishes, external works. And under each of these pricing items, we have a worksheet with our labor calculations, but also our materials, subcontractor, and plant calculations. Now, for us to accurately determine the hours we need to allocate to that task, the next thing we need to work out, is it a production-based task or is it a program-based task? Production-based task means the quantity of work drives the durations. It means you're doing a task where there's no constraints, you have clear access, and the total hours we need for the task is directly proportional to the volume of work you have to do. For example, you have a civil crew, they can trench 50 meters per day. There's 1,000 meters of trenching to do. The hours for that task is going to be the civil crew for the 20 days. The other type of task we can have is a program-based task where there's some other sort of bottleneck that is determining the duration a task takes. So say, for example, we have that same civil crew, they can trench and backfill 50 meters per day, but we're installing some underground welded pipe, and the pipe install crew can only do 30 meters per day. That means the civil crew is limited by the speed that the pipe install crew is going. So they can't actually do more than 30 meters of trenching and backfill per day. So even though their actual productivity rate would be 50 meters per day, they're limited by the program of the pipe install. So the productivity we would have to use in this is 30 meters per day. So instead of allowing for 20 days for this task, we would need to allow for whatever 1,000 by 30 is, which I think is like 33. So the key question to ask, I use the terms production and program based, but you just really need to understand this question. What is driving the duration of the task? The next step in this process is we need to convert the quantity of work into man hours. Again, if it's a program-based task, you do this off the overall duration of the task. But if it's a quantity-driven task, all we do is take the quantity of work and multiply it by our production rate, assuming you have the units around the right way. Some people get confused and they'll multiply, say divide 100 by divided by 2, which would be wrong. You have to pay attention to these units. For example, this formwork activity, I'm measuring in the number of hours per meter squared of formwork. So if I times by the quantity of formwork, I get the number of hours. But some people write productivities as how many meters squared someone could do per hour. So in that example, the correct production rate would be 0.5. So all you have to do, and then you divide the quantity by the production rate. Again, pay attention to your numbers, make sure you have the units around the right way. Again, if it's a program-based task, not a production-based task, simply, instead of using the production for the task, you use the program constraint. Example, pipe install is 30 meters per day, which gives you the total man hours. So little things to pay attention to is often we talk of, like for the formwork example, because it's one person doing formwork, I'm talking about that individual. Often you'll have to do this using a gang rate. So a gang rate would be some combination of resources like labor and plant. So for example, trenching, we might have 2 laborers and an excavator. So that rate we would use, we would build up the combination of 2 laborers and an excavator, whatever that would cost per hour, and that would be the hour we use. So for example, 50 meters per day, say it's 20 days, that would be 40 man days because we have 2 laborers. Again, simple concept, but you just have to pay attention that you're accurately calculating all this stuff. Okay, to put it all together, the very complicated formula to finish with, our total labor cost for the project is simply the hourly rate multiplied by the man hours. The maths is easy, making sure that all the input numbers that go into the hourly rate and the man hours, again, is the hard part. So the questions you have to answer before you submit your labor estimate, before you calculate your labor estimate, is do you understand how your labor rate was built up? Have you included the right on cost? Do your productivities include or exclude non-productive time? For each task, did you determine correctly whether it's production or program-based, and have you clearly documented your assumptions around this? Again, I can't give you the exact numbers, but this is the process I use to think through my labor estimates to avoid missing scope, double counting, and undercounting. Are you constantly finding your budgets for plant never align with your actual costs? Most contractors I see tend to just ignore this, and to be honest, because plant in most cases tends to be a small percentage of the overall project costs, they can get away with it. But estimating and managing plant costs is actually incredibly easy to do, and on top of that, it gives you a lot of opportunities for variations if you manage it strategically and proactively using a strategy called plant balancing. So in this video, I'll give you a complete guide to estimating plant costs accurately and talk about how to qualify and manage this in your tender submissions to give you additional opportunities for profit. Okay, so how do we estimate plant costs the right way? Well, first let's start by actually defining plant costs. Plant is basically any machinery used to perform work. Excavators, cranes, pumps, generators, telehandlers, whatever. I would exclude small tools from this, and I would always calculate small tools and consumable items like drills, whatever, and I would roll those into labor on costs and just allow for some budget per project for small tools. This is more about large plants and equipment. You could include in there things like compressors, welders, lighting towers, whatever, but really I would exclude small tools because generally you don't have to calculate things in that much detail. Wet hire items from subcontractors where you're getting a rate which has labor and plant in it, I would also call a plant cost, but you may prefer to split out the labor and plant materials. Again, a lot of this stuff, there's no set rule. You just have to make sure you're counting everything properly and you're not double counting things. So in general, plants would be something sort of equipment that has a rate that must be scheduled and allowed for, not things like small tools. So calculating plant costs is unbelievably simple. You have your plant rate, which is your daily, weekly cost to the project of having the plant on site, multiplied by a higher duration, how long you want the plant for, plus the mobilization and demobilization costs. So these are the fixed costs with getting the plant set up on your project. So let's look at part A of this, which is accurately calculating the plant rate. That is going to be driven by whether you own the plants or whether you hire the plants. Now, for the owned plant rate, basically, even though you own the piece of equipment, you need to build up what's referred to as a cost recovery rate. This is the rate you bill the project or you allocate to the project on your estimate to recover the cost to the plant. This is going to be a function of the upfront purchase price, any financing costs, the useful life and the depreciation you allocate to the plant, any sort of planned maintenance, repairs and breakdown allowances, insurance, registration and compliance, and also the utilization of the plant across projects. For example, if you're only billing a piece of plant or a project 75% of the time, you need to bill a higher rate to recover that from the project than if you're billing it out to projects 100% of the time. Now, another point I'd make here about how or why it's important to understand your cost recovery rate for owned plant is that you'll probably find it's way higher than what you actually think it is. And while it seems like when you get rates from suppliers, they seem very high, in a lot of ways, you'll probably find that the owned rate is a lot higher than what you actually think it is. And if it is higher than a higher rate, which is probably going to be majority driven by the utilization percentage across projects, then you should be selling that and boosting your cash flow. So if I look at a little example of this, say you spend $60,000 on $80,000 on a ute, and 4 years later you can sell it for $20,000. That means you need to depreciate the piece of plant by $15,000 per year. That's obviously an extreme example, but I'm just coming up with these numbers in my head. Then per year, you need to spend $100 a week on fuel, which is $5,000, $2,000 for servicing, $2,000 to fit it out with fire extinguishers, lights, whatever you need, and $2,000 extra. That gives you an annual running cost of that bit of plant for $26,000 a year. If it's 100% utilized, that would equate to an hourly rate of $14.87 per hour. That would assume 2,000 hours per year. But again, if this utilization drops to 50%, then that rate would actually double. So it's very important what percent of your time you're allocating that plant to projects. Now, for hired plant, much simpler. Our supplier is just going to give us either a daily or in some instances, maybe for wet hire, they'd give us an hourly rate, but typically it would be a daily rate. Now, these rates can either be dry hire or wet hire coming with an operator. With hired plants, we always need to pay attention to what's included in these terms and conditions. Wet hire plants for a crane for a couple of hours, you're not going to need to allow for servicing, fuel, whatever. But if you've got long-term hire of equipment, you may have to allow for some of these additional costs. On top of that project cost recovery rate, we've also got our operating costs of plant. These are going to be things like fuel, tolls, parking, consumables, standby charges, overtime or weekend surcharges. And if we're getting billed for it from a subcontractor, travel to and from the depot. Again, you just really need to understand basically the terms and conditions of the supply agreement, or for any owned plant, what all the costs actually are of running that. Now, in addition to the ongoing costs of the plant, we're always going to have some sort of mobilization and demobilization cost. For some cranes or huge bits of equipment, this is unbelievably big. I'm not sure if you've ever seen them setting up a major crawler crane, but often they'll have a second crane come in just to assemble that crane. So for things like large cranes, it can be a massive cost. But these are just costs like the transporting to or from site, escort vehicles, any labor to load or unload, travel time, any inductions, site inductions has to get done, or any site-specific setup and configuration. For small items like utes, you can ignore it. But for large cranes, large bits of plant, this cost will be massive. Once we have considered all these costs, we're going to have both our day or weekly plant rate and our mob and demob rate, which leads us into the next step, which is then calculating the hire duration. And the first part of this is exactly the same as any sort of labor cost estimate, where basically we would follow the same approaches we're doing with labor, and you would almost always do it in parallel with labor because, again, until they have autonomous cars, if there is plant we're using, there's going to be some sort of operator. But basically, it's the same approach we do for any estimate, which is where we just break down the project scope into different packages. We work out the methodology, so what labor and plant we require. We quantify each task. We apply a production rate to calculate the duration, and this is going to give us how long the plant is needed or how many productive hours we need the plant. Note, I'm saying productive because that's an important term I'm going to explain in a second. Do I use an example? So for example, for trenching, where we have an operator, a spotter, and an excavator, that is our going rate for the task, so that the resources we require. We've got 1,200 meters of trenching. We're doing 30 meters a day. We've got 40 days of that excavator on site. Okay, so this is where it differentiates itself from labor. Plant often has much more non-productive time associated with it than labor. That's because of sequencing of works, access of trades, hold points, sequencing. Basically, plants will almost always have much more idle time as opposed to labor, which is almost always continuous because you don't really tend to have people at work and not working. Let me do a little example. Say we're building this oil and gas facility and we've got this massive crane, but we only need it to install 4 items. If we can do all those 4 items in sequence, there's going to be 0 idle time. There is almost certainly that's almost certainly not going to be possible just because of the sequence of construction, the way it plays out. Typically, between all these activities, there's going to be gaps. That means for any plants we bring on site, we've got to answer an important question. Do we want to keep it on site for the entire duration that it's required? Or do we want to pay for mobilization and demobilization? So to effectively calculate but also optimize our plant costs, we need to do something called a plant balancing. Say for example, with the excavator we've got on site, we're going to use it for 3 weeks to do trench 1. Then we've got our Christmas shutdown. We're then going to need it for 2 weeks in January to do trench 2. But then for whatever reason, during this period of time, there's other works going on and we can't do the trenching. There's going to be a gap. Then we've got another 3 week trench we need it for, which is continuous, another gap, and then 2 weeks we're going to need it for this trench. Following this methodology, using this approach, all we've allowed for is the actual time the plant was productive. So 3 weeks plus 2 weeks plus 8 weeks plus 10 weeks. But if we look at this overall, the plant is going to be on site for 15 weeks, not the 10 weeks that is currently in our estimate. Now, there's 2 ways we can tackle this. We can demob and remob the plant every time we need it separately, but all that's going to do is probably massively increase our mobilization costs if we're talking about something like an excavator, or we can have it on site and pay for idle time. This process of going through and working out what is the optimal way to do this, how many mobilizations you need, how much additional idle time do you have to allow for, is referred to as plant balancing. And to do plant balancing effectively, you need a rough schedule or sequence of the work. I was going to give you a template of this Excel spreadsheet, but it is literally as simple as that. You just have your dates and you just map out when the plant is required. Some instances, you'll actually be able to reshuffle the order to optimize this. Maybe you can do trench 4 during this period, so you actually cut down the total amount of time. Basically, what you're trying to work out is how many mobilizations and demobilizations you're going to allow for and how much idle time you're going to allow for. And then in your overhead costs or your indirect costs, you just allow for a plant balancing figure, which covers these additional weeks the plant is on site and not productive and covers the number of mobilizations. So this is an example of the plant balance figure. So say we need to allow an extra 10 days of non-productive time of our EWP and we want to allow 4 mobilizations. This would be, you then allow for this in your indirect costs, and then because you don't want to show it to your client, this plant balance figure is then spread across your direct costs. Now, this is where I would say if you are not in control of the schedule and you can't manage that risk associated with on-hiring and off-hiring and access and continuous work, you should be qualifying this in your tender submission. So in your tender submission, you should be crystal clear based on the schedule they've provided or the methodology you've chosen. We've allowed for 2 mobilizations, 4 mobilizations, 1 mobilization, whatever. That should always be in your letter of offer and your submission. If you're the one who's screwing up the mobilizations, you can't qualify this. But if, for example, you've allowed for 1 crane to install all the structural steel, and that is contingent on your client being able to provide you all the structural steel in time, then you should say that in your letter of offer and your tender submission. We've allowed for 1 mobilization on the crane. If during construction then the client is delayed in receiving materials, you've got to allow for multiple mobilizations, additional idle time in the crane. That is something, if you've drafted the scope of works properly, you've negotiated the contract, that is something you should be able to claim for. So that's why if you are not in control of the schedule, your client's in control of the schedule and they're dictating this stuff to you, you should always qualify things like this in your letter of offer. But that's calculating plant costs. It's unbelievably easy. All it is working out the rate we're going to charge, the high duration, and how many mobilizations and demobilizations we need. While materials tend to be a big part of project costs, they are incredibly easy to price. Unlike things like labor, where there's all these compounding variables that impact each other, materials is really just working out what we need to buy and then getting quotes for it. The challenge with materials is typically surrounding the cost of materials. There's all these little things we need to allow for. Has the supplier offered us the correct warranty? Have we factored in delivery? Do we need to allow for spare parts? And have we factored in storage costs? On top of that, there's also some really effective strategies used by billion-dollar contractors to get effective pricing for materials and manage the risks in price volatility. So in this video, I'm going to give you a simple step-by-step guide to accurately pricing construction material costs and getting value for money and reducing risks. Okay, so let's go through how to estimate construction material costs the right way. Where do materials fit in? Well, they're just one of our construction direct costs made up of labor, plant, materials, and subcontract costs. And estimating materials ultimately comes down to two very simple questions. What do we need to buy and how much of it do we need? So step one in this insanely complicated process is to identify what materials you need. Now, there's really two sources of requirements for materials. In the drawings, we might have an explicit product nominated, in which case, very easy, that's the product we have to get quotes for. Or the alternative is we'll have some sort of material specification or performance requirement. So instead of specifying some exact product or supplier we need to go to, the drawings will just say something like, we need to provide 32 MPa concrete. Now, with this specified item, it's generally easier. The drawings will just tell us exactly what we need to get. For example, ChemSet Rio 502 or approved equivalent. It's telling us the exact product we want. With performance requirements, there's a little bit more complexity, but also a little bit more opportunity because choosing the supplier we go to is our decision, our risk. So we need to find a supplier that matches the performance requirements, but also we need to find the lowest cost possible product. So where we're choosing the product that we buy, for simple, straightforward products like conduits, consumables, things like that, it's generally straightforward and not really a problem. But for complicated systems or products with a lot of variability in them like concrete, we have this additional step where we need to find the product that we can use and that it aligns with the design requirements. Now, I would always get the product choice we've used approved by our client or the designers. This is often referred to as the shop drawing stage or the product supplier check, or maybe even if it's an architectural project, you might have to give them samples to show different colors. But basically, it's getting sign off before we buy that what we're buying is correct. Particularly projects and project engineers, I've noticed, will quite often skip this step, which to me sort of blows my mind because they're choosing to take on the responsibility that they've determined the product is correct when quite often it's better to get your client or the architect to do this for you, to give you a tick of approval, because then they're taking the accountability and responsibility. So one important qualification as well is because we're pricing materials during pre-construction, the challenge will be that we probably won't have enough time to get the product approved for use by our clients or the designer. So in practice, while during a construction project, you've got more time to go through the whole process of getting and vetting quotes, getting product specifications approved. During the tendering phase, you probably won't be able to engage a designer, or your client probably won't respond to you if you ask them to approve the products you're using. So in practice, a lot of the time during tendering is you will have to take on the onus of checking the product specifications match the design requirements. Okay, so at the end of step one, we basically know exactly what product we need to buy. Step two, very complicated, is to determine how much of that specific product we need. Okay, so there's three components to answering this question. We've got the construction quantity, what we're going to use during construction, wastage, what we're likely to waste during the construction process, either through damage or losing things or just lost material on site. The final part is any spare part requirements in the contract? So as part of the project completion requirements, we may have to hand over a certain number of light fittings or products that we've used during construction. So we also need to pay attention to spare parts. So I probably don't have to tell you how to do this, but basically to get the construction quantities, we do quantity takeoff. If you don't understand how to read construction drawings, if you understand what you're building, very, very easy. You need to work out things like the meters cubed of concrete, the tons of structural steel, the lineal meters of conduits, the number of light fittings, valves, fixtures, whatever. It's very, very simple. The one extension to this concept that I think is relevant when pricing materials during construction is often during tendering, you won't have enough time to do intricately detailed quantity takeoffs for every single item. For example, if you're quickly pricing a concrete construction project, you probably won't actually have time to measure the length of every single bar and work out the weight in tons exactly of what steel reinforcement you need. Or for example, if you don't have a detailed design for an electrical layout, you wouldn't have all the sub-circuits scheduled, so you wouldn't know the lengths of all the circuit cables exactly. The way to address this challenge during the tendering phase is to simply use some rules of thumb to derive secondary quantities. This is basically where we measure a primary quantity, like the quantity of concrete in a structure. Then instead of doing a steel reinforcement takeoff, we use some heuristic like the ratio of steel to meters cubed of concrete in a typical slab to determine the quantity of steel reinforcement. So say, for example, we've got 100 meters cubed of concrete, and we know in a typical slab, we get about 120 kilograms per meters cubed. That gives us 12 tons of steel reinforcement in the concrete slab. That is just a standard ratio. You can look them up online depending on the types of structures you're doing. You can also derive these yourself just using sort of common sense and understanding the construction methodology. Say, for example, you don't have the circuit cable schedule that shows exactly how many meters of cable go to each light fitting. You can use a rule of thumb with something like each light fitting needs 15 meters of cable, which is just basically the distance from the closest switch to the light fitting. You know that it'll need 2 glands, one for either end of the cable, and then a certain amount of cable ties or so on. And then you can just apply this quantity to your primary quantity, which will be the number of light fittings, to derive the secondary quantities. Stuff like that will save you a ton of time and almost be as accurate as doing the other 90% of the work, which would be measuring all these secondary quantities. And in purpose of quoting projects, it's likely just not worth it because these secondary quantities tend to be for cheaper, more consumable type items. Now, again, common sense, but if it's forgotten, it'll be missing from a quote, is that you're not ever going to use exact quantities of items. If the slab has 100 meters cubed of concrete in it, you're probably going to lose a little bit of concrete. For example, if it's an earth-formed slab and you don't have formwork around the edges, you'll have additional concrete wastage. Or if you're cutting and bending steel reinforcement, you'll have some wastage associated with it. Really, it depends on the project specifics of how you're building it and the material type, but you should always allow some percentage wastage for quantities like concrete, crushed rock, formwork. For items like light fittings and things like that, where you've got, say, 10 types of different products, it wouldn't make sense to allow for a separate light fitting for every single type of light fitting because you're just going to end up with a huge amount of redundant contingency, and it wouldn't really make sense. For those sort of items, I would allow a central bucket of money for replacement of damaged parts. The final quantity we need to allow for are any spare parts required in the contract. For most civil construction projects or civil contractors, this won't be relevant, but particularly if you're doing like mechanical, electrical, service types work, the contracts will almost always specify that you need to provide spare parts or some handover parts as requirements. So this might be things like 2% extra light fittings, spare filters, pumps, specialized components, whatever. If it says it in the contract, you just need to make sure you're allowing for it in your bill of materials. Now, exactly like we would do if we're getting quotes from subcontractors, all we do for our materials is send our bill of quantities out to suppliers and get quotes back. I covered this in tons and tons of detail in the subcontractor estimating video, so you can check that out if you want, but particularly with materials, these are the inclusions I would ensure are in my RFQ. Obviously, use common sense, adjust by the package you're getting quotes for. I would include the exact quantities you want. Don't rely on the supplier to do the bill of materials. I think that is just gonna create you problems down the line, particularly if they're just quoting for a tender and they know you haven't secured the project. Give them detailed specifications and data sheets, or if you need to get their product approved for compliance, you would need to request that from them. Tell them all about delivery requirements, access constraints, what are their offloading requirements, so they need to provide a crane or a forklift or whatever. Is delivery going to be in one batch? Is it going to be multiple batches? What are your head contract warranty requirements and conditions? Pass those on to the supplier. Are you requesting installation manuals? Do you need them to prepare operations and maintenance documentation? In some instances, for special products, depending on your contractor requirements, you might actually have to get training from the supplier to provide to your client. Do you need FAT testing, different types of test certificates? What are any compliance requirements you're responsible for? Do you need them to actually help with commissioning assistance? Obviously, because I've worked on a lot of solar farms in the past, that actually ends up being a huge portion of the project cost for any sort of specialist materials like inverters or trackers, and site or owner training, which I already mentioned, and basically package and handling requirements, and also what they should exclude if you were going to do certain things like the offloading or manage the delivery, so you're not double counting the costs. Now, again, exactly as per the subcontract management video I was talking about, this is an example with a subcontractor using my estimating software Opera, but basically you break down the supplier quotes, you compare multiple quotes together, you get 3 to 5 quotes from correct suppliers, and then you adjust the quotes based on their exclusions or ask them to reprice based on their exclusions. So you're comparing apples to apples. But again, importantly with materials, you need to properly vet and check technical specifications. Then based on their inclusions and exclusions, comparing apples to apples, making sure they meet the technical specifications, pick the lowest cost technically compliant quote, not necessarily the cheapest one. You need a technically compliant quote. All right, so once we then got our quotes from our suppliers for the correct materials, the next thing we need to think about are any additional cost considerations. And while these might not necessarily be material cost, we still have to cover them somewhere. So usually the best prompt for thinking about what additional costs are associated with the materials is to go through the materials we're ordering and working through the logistics, the handling, and these sorts of things. So by logistics and handling, I mean, where are they getting delivered? Where are they getting stored? How are they getting transported from where you're storing them to where you're installing them? Where are they getting stored? Do they need to be undercover? All these things have to be thought about. Now, the other thing that is more of a strategy big companies use is if there are buying gains from group procurement policies, how are they factored into the project? Say, for example, you're a large civil construction project and your general manager or owner negotiates a deal with a steel reinforcement company that says they're committing to this huge volume of orders across a year or 2 years, and based on this quantity, they're getting discounted prices. How is that factored into your pricing? Do you have a specific rates you're using? Are there preferred supplier agreements? Are there discount structures? Basically, you have to consider that stuff because that is a strategy all the big contractors use to drive down their material costs. The next thing I would consider is how the material choice you're making at this stage have any flow-on effect to your plant and labor requirements. This is more of a philosophical thing, but I would always prefer to spend more money on materials because I think there's less risk in material prices, for example, using precast rather than in-situ concrete or modular wiring versus traditional installation of cables. But basically, it's where you might have to make some cost-benefit analysis decisions between the materials you're choosing and your labor and plant costs. The next thing you should consider is for lead times of materials and the cascading impact this has on your schedule. For example, if you're ordering materials, they have a very long lead time. If you increase the overall duration of the project, you increase your preliminary costs, it will always make sense to buy more expensive materials that you get faster, because there's obviously going to be situations where this doesn't apply, but I would say 9 times out of 10, if you can get something faster, it impacts your critical path and reduces the duration of the project, you will almost be financially better off to spend more on materials. So you need to consider that when you're looking at the different suppliers. Now, the next thing you need to consider are market and supply chain conditions. This is where you have to think about variability in things like the cost of copper if you're procuring electrical cables, in steel if you're ordering reinforcement or structural steel. These sorts of market supply conditions may impact your cost of materials. Now, you often see for an electrical wholesaler, they'll put a term on their offer that says these prices are based on variability of copper prices of less than plus or minus 10% from when they've made the offer. It's basically, you just have to consider how these sort of factors outside your control are either de-risked in your contract, whether you pass that same exclusion onto your clients, or you're managing that with your supply chain. For example, they're locking in certain rates with you and they're happy to hold that validity to when you actually need to order the materials and the products. You just have to think about that risk, because with things like Ukraine and the price of aluminium, or COVID and what it did to international shipping out of China, that it is something you have to consider with materials. Because like previously I was just saying that materials have a lot less risk, but there are these market conditions that generally you don't get with labor and subcontract costs. But with materials, you can get quite rapid and volatile price changes. And you just have to consider both how you're de-risking that to your clients and how you're managing that with your supply chain, because you don't want to get caught in between. And finally, this is just something to think about as well. You'll often have to get test certificates and compliance checks for the materials. Just need to check, is that something your supplier is going to cover and do? And are test methods appropriate for what you have to provide to your client? Or are you doing independent checks? In which case, where is that cost covered? And I'm not sure if you've been noticing, but I've been fixing spelling mistakes we're going through. I don't know what I was thinking when I wrote this, but final thing is step 6 to build your material cost estimate. And this is basically taking the rates you've applied and applying a quantity. Very, very simple. I was thinking about doing a worked example, but I'm assuming you can multiply and derive quantities, so it's probably not even worth it. So the final thing I want to talk about is basically a commercial strategy you can use to get better material pricing at less risk. So this is the strategies big contractors use. They focus on getting buying gains across projects. So they go to things like their suppliers and say, we've got these 10 contracts we've just signed or about to sign. We're going to buy sort of this volume of steel reinforcement, concrete, whatever. What's the best possible rate you can do it? Because again, suppliers want big volumes of orders. And if they get offered large packages to quote for, they'll give you better rates than if you're giving them tiny orders. That's referred to as a group procurement process. And that's going to help you to leverage market competition because you're getting multiple quotes for big packages of works. And I guarantee if you do that, you'll get better rates than if you're individually packaging things up project by project. The next thing you can do is to standardize preferred suppliers. So have a panel of suppliers you always go to that you know provide technically compliant requirements, that they're easy to work with, that they always factor in their lead times, that they're reliable, and that you're not going to run into other issues down the line. That's basically going to both speed up your procurement process and de-risk your project. And then the final thing is just to avoid late RFQs. You can manage stuff so much more effectively by just buying everything at the start of the project as early as possible. And you're going to get caught in these positions where you're rushing to place an order and paying acceleration and higher prices to get stuff faster. Don't you hate clients who send you a 200-page tender package full of useless information and give you 5 days to price? It sucks. So why do you do the same to your own subcontractors? The only way to accurately estimate subcontractor costs on a construction project is to get accurate quotes from your subcontractors. While this doesn't sound like rocket science, the key is to spoon feed them the information they need and make it as easy as possible for them to quote your project accurately. Basically, you can't treat them like your clients probably treat you. In this video, I'm going to give you a complete system to accurately estimating subcontractor costs and including them in your tender submissions. I'll also give you some very effective strategies I've seen over the years at large construction companies they use to de-risk their procurement. Because unlike labor, plant, material, and other cost items, subcontractor costs are as much, if not more, about contract management and administration than they are about estimating. So the first thing I want to start with is a quote a subcontractor sends you is not an estimate. They are fundamentally different. Yes, to accurately estimate subcontractor costs, you do need subcontractor quotes, but if all you're doing is plugging your subcontractor quotes into your estimates, you are leaving yourself very exposed. the end of the day, we're estimating what it will cost us to subcontract the work, not just the subcontractor quote. This means we have to include things like scope gaps, exclusions, variations, delay, default risk. What happens if your subcontractor goes broke? Our job is to determine the true allowance needed in our bid. This is fundamentally much more difficult than taking a quote and plugging it into a spreadsheet. We have to deal with procurement, how to get value for money from the supply chain, then how to properly assess and level bids, and then select what price to include in our estimate. Because at the end of the day, we are ultimately responsible for the performance of our subcontractors, so we need to budget for the true cost of them completing the work. Step one in this process starts with building the correct subcontractor package list. The goal in this first step is to take the overall project scope and break it down into component, logical, ready-made packages. To give you an example of what I'm talking about, here is an example project work breakdown structure or a procurement package list. This is done in my estimating software Opera, and you can see we've taken a commercial construction project, we've broken it down into some preliminary packages, and also all of our construction packages such as earthworks, concrete works, structural steel, mechanical services, fit out, and so on. So basically, we've taken the project scope and we've worked out a list of packages we need to procure from the market. This is the most important decision that will have the greatest impact on your project costs during the estimating process, particularly if you're a general contractor that subcontracts out the majority of the work. The way you structure and manage your packages is the biggest determinant of the cost of managing those packages. We want to do it in a way that maximizes and leverages market competition, but doesn't leave us having to manage 1,000 tiny different packages and run into a whole lot of coordination issues during construction. So there's a real art to doing this effectively. I think what we in general should be striving for in a competitive market is we don't want margin on margin. So we don't want our subcontractors to subcontract our work. Now, there's obviously going to be exceptions to this rule. For example, if we're procuring an earthworks package and the subcontractor subcontracts out their compaction test, it's a tiny portion of the work. We don't want to deal with the hassle of having to free issue and coordinate compaction tests with them. But in general, we shouldn't have our subcontractors subcontracting out major packages of works, because then we're just paying for margin on margin. When we create this package list, the goal should be to have these packages comprehensive and mutually exclusive. There shouldn't be overlapping scope and there shouldn't be missing scope. Missing scope is going to end up with a variation during construction. Overlapping scope is going to result in us double pricing and artificially inflating our price. Now, the way I like to do this, and once you start using it, it'll change your life forever, are battery limit drawings and scope interface summary. For example, say we're on a building construction project and we have structural steel and some sort of facade or cladding. We simply mark up on a drawing. Now, this was a crappy version I did, but you can make it way better by highlighting these items, writing notes. Basically, we mark up on the drawings exactly what each contractor is going to be doing, and we note it down into some sort of scope summary matrix. That is going to make your life so much easier. So you can write all this in a scope of works, or you can just mark it up on a set of drawings that everybody sees. Now, the next step, once we've worked out our overall subcontract packages and the overall procurement approach to the project, the next step, using this as a basis, is we then prepare high quality tender packages. Now, you don't want to do, as I said at the beginning, you don't want to do what your clients do to you and just create these mammoth tender packages full of every project document that's full of irrelevant information. I was working on a concrete subcontract bid, and our client sent us all their electrical lockout tagout process. Now, the reason they do this, I think, as a side note, I think is actually incredibly unfair, because the reason they're doing that is they're attaching every possible document. So if any issue comes up during construction, they can refer back to it and say, well, you had access to it and you should have redone. I think that's insanely unfair, but your clients probably do try to do it to you. So can't do much about that. I think you shouldn't do that to your subcontractors, because particularly when you're tendering the work, if you send them way too much information, all they're going to do is exclude a whole lot of stuff, qualify their price. They're not going to put the time and effort into analyzing it properly. You're going to end up with a whole lot of different exclusions from different subcontractors. So the best thing you can do is have high quality, condensed, easy to understand concise scope of works, set of drawings, supporting information that spells out crystal clear exactly what you want them to price and what format you want to return it in. The litmus test I like to use when I'm preparing a scope of works or someone to quote something is it should have enough information in it. Is it that if you were the estimator, you could price it? So you need to take the perspective of the estimator looking at the documentation. Every question they're going to have, is that spelled out in your scope of works? Who's doing the excavation? Who's supplying the concrete, reinforcement, embedment items? Who's doing the penetrations? Are we doing testing, QA requirements? How many mobilizations are we doing? What's the schedule? Every single thing should be in there. The next thing you always want to do with your scopes of works and tender package, which is a risk management exercise, is you want back-to-back requirements. What that means is in your tender package, your head contractor requirements, you want to pass those down to your subcontractor wherever possible. For example, if your contract has a 24-month defect liability, you want to get a 24-month defect liability from your subcontractors. If you are responsible for a certain concrete testing specification, you want to make sure your subcontractor has access to that specification and they're pricing to do that sort of testing. Basically, anything you are responsible in relation to the package of works relevant to your subcontractor, you want them to also be responsible to it. That's referred to as back-to-back contracting and is an essential contract management and risk management exercise. The next step after this is you want to issue this to 3 to 5 qualified subcontractors. Now, I understand that sometimes people will have preferred subcontractors because they've got good relationships with them, and that obviously makes sense if you've done that. But again, most of the time we'll be operating in highly competitive markets, and if we do have cherry-picked preferred subcontractors, unless we're very confident they're pricing stuff fairly to us, all we're going to do is probably artificially increase our price and reduce the chances of us winning the work. So unfortunately, construction is a competitive environment. Your clients will get 3 quotes to check your price against, so you should also have numerous qualified subcontractors that you trust, that you're happy to work with. You should be getting 3 to 5 quotes for every single package. Now, the goal here isn't just to send it out to any 3 to 5 random subcontractors. It's 3 to 5 subcontractors that you would be very happy if they were able to do the work. They should have good quality records, safety records. They should have good relationships with you. They should have high quality project managers and project teams. Really, you want to find subcontractors that you would actually be happy to award the project to. And again, if you do have subcontractors that you have very good relationships with and you're confident that they're pricing stuff fairly to you, it doesn't necessarily make sense to get multiple quotes, but a lot of the time you probably will need to be getting multiple quotes to ensure people are pricing stuff fairly and you're leveraging market competition. Once you issue the quotes, basically you want to manage the tender effectively. You should call them almost immediately after you send the tender package to ask any questions, explain that you can have a meeting to discuss it with them, because basically the more information you give them, the better their price is going to be. I would also, in the email that I send them, make sure any specific project requirements are absolutely clear and spelled out to them. And all this is going to do is increase the chance that you get accurate quotes. Now, once you do get your quotes back from them, every quote they give you is going to have different inclusions, exclusions, assumptions, clarifications. So what you need to do is you need to look at the quotes you get. You need to level the bids. What this is, it's the process of clarifying scope gaps. You can either go back to the subcontractor and ask them to update their price to include your requirement, or you can simply make allowances for it. The other thing you can do at this stage, which makes sense for large packages where you would potentially be able to self-perform it, is you can do a self-perform check. This is where you work out the price of hiring your own labor, plant, materials, and doing the work yourself. This is going to have 2 benefits. One, it's going to help you confirm that you're getting good value for money pricing from your subcontractors. The second one is it's going to also give you another option. If the savings are significant, you could potentially look at self-performing it. It's all about optimizing the methodology. So the goal of this step fundamentally is we're taking 3 to 5 inconsistent quotes and we want to transform them into an apples to apples comparison. So I'll give you a quick example of what this looks like. Again, me shamelessly promoting Operum, but here are 3 quotes for different civil contractors. We've got the pricing schedule that we issued to them at tender. Each of them has filled this out. And then we've got specific adjustments to their quote. For example, Melbourne excavations didn't include wet weather allowances, so we budgeted for that and then have adjusted and have a total leveled price for each subcontract, and then can look at which one of these we want to include in our estimate. And then once you understand the subcontractor quotes, the next step is relatively easy. You have to choose which one to include in your bid. Basically, what you shouldn't do is include the lowest price, because that's the one with the most risk associated with it. It's the one the subcontractor is most likely to have underquoted something, but you can include the lowest price if you are very confident in how they put it together. Basically, this step is we're determining which of these quotes to include in our estimate, which one is going to reflect the true cost of doing the work. Then we have to determine any risk, contingencies, and scope gaps we need to budget for. Because again, the cost to us of the subcontractor doing this work is the quote they have given us, plus any uncertainty associated with it, scope gaps, variations, or any missing items. For instance, for this quote, which was fabricating, installing structural steel, we had to make an allowance for consumables that they weren't including in their quote. That's just an example of a specific scope gap. You can use a different approach where you have common risk allowances across all packages for things like variations, coordination issues, escalation, default performance issues, rework and delays, missing quantities, head contract obligations not included in pricing items. These sorts of common risk allowances across subcontracts, I would typically include as a percentage allowance in my overall estimate. Where if you know there are specific gaps for specific packages, i.e. the missing consumables for the structural steel fabricate and install, you could include that directly in the structural steel package. Again, depends entirely on the project you're quoting, but it's just understanding what additional allowances you have to make on top of the quote to make sure you're going to have enough money to deliver the project. And that's pretty much it. We've gone from our original project scope, broken it down into packages, and then determined exactly what amount to include our estimate. Final thing I want to talk about is a strategy that big contractors, large general contracting firms do that I think is unbelievably smart. And it's basically they do their procurement for major items during the pre-construction tendering phase. What this means is basically they issue their packages, do all their procurement, they sign subcontracts that will be executed when their head contract's signed. So as soon as they get the go-ahead from their client, all their procurement's done, and they have zero risk associated with the rates from the subcontractor because they've already locked those in during the tender phase. So for example, you see this a lot in solar farms with the big EPCs where they've got maybe 70 or 80% of the total project costs is materials. So for example, for a solar farm, they'll get quotes for the panels, the trackers, the inverters, all these items. They'll lock that in during the pre-contract phase. They'll basically sign a contract with their subcontractor to supply all the panels that will get executed when they execute the head contract. Then as soon as they sign the head contract, as soon as they get given the go-ahead to build the solar farm, they sign the purchase order to order the panels, and that price that is included in their tender is the exact same as what they use to buy the panels. So there's zero escalation risk, there's zero scope gap risk. Well, I actually shouldn't say that. There's not zero scope gap risk because they might not have done the procurement properly at tender, but basically the price that they've done their procurement at tender with is the same as what they're going to use in project execution. The other massive benefit I see to this, and that it kind of like surprises me more companies don't do it, but you're only doing your procurement once. Almost every project I've worked on, you do the procurement during the tender, they go and get quotes for everyone. Then 3 months later, after the project's executed, the project team does the exact same thing. Not only does this annoy all your subcontractors, but basically you're doing the exact same work twice. Now, I understand the specific reasons for this. Maybe the project team has different opinions to the tender team, or there's been design development and changes, but as much as possible, you shouldn't try to redo your procurement. You should only be doing your procurement once, and that should be during the tender phase. Okay, to quickly recap and go through this system. First step is we want to create our packages, build our work breakdown structure, identify all the scope interfaces, and create our battery limit drawings. Again, battery limit drawings are life-changing. Then once we have our clearly defined tender packages, once we have our clearly defined project scope work breakdown structure, we then prepare our clean, clear, accurate tender packages. We issue them to 3 to 5 qualified subcontractors. We review the quotes, level them, adjust them, identify any gaps. We select the correct allowance to include in our bid. We then add realistic subcontract risk allowances and money for any gaps. And that is our procurement. That's how we get the correct subcontract value to include in our estimate. And for major scope items, we should be basically signing some sort of pre-tender agreement so our price is locked in. How do you accurately calculate construction overhead costs? A lot of contractors I know just apply a huge gross markup to their direct costs and hope for the best. Surprise, surprise, this isn't the best strategy. As I'm going to show you, understanding and pricing your indirect costs accurately is going to obviously help you prepare more accurate construction estimates, but importantly, as you'll see, it's going to give you more opportunities for profit during construction. So let me show you exactly how to do it. Overhead costs are simply the costs required to run a construction project, not directly related to physically doing the work. So these are things like project managers' salaries, security fencing around a construction site, or even a security guard that's there overnight to prevent thefts and break-ins. This is opposite to direct costs. So these are the direct costs are the costs of the things that we physically create. Things like pouring concrete, installing cables, or supplying and installing structural steel. Now, one critical thing to note, and I'm a little bit torn around the correct terminology here to use, particularly in my estimating software Opera, is that often your indirect costs aren't shown in your client pricing schedule. So there might be a line item in your pricing schedule for preliminaries and project management, but you typically wouldn't have a line item for things like risk allowances or bank guarantees. Now, I generally think the best rule of thumb is to always add a line item for things like project management salaries and your recurring overhead costs that your clients can easily understand, but not to do so for items like risk allowances or bank guarantees that you don't want your client to see. This way, these items you would spread across your direct costs. Now, the lines blur between direct and indirect costs. There's different ways you can classify them. It's all going to depend on your project. The way you classify your overhead costs completely depends on the scope of your project. I like the rule of classifying something as an indirect cost if it is driven by the project duration or some other variable like total labor hours or total subcontract costs. On top of that, I would also classify something as an indirect cost if it doesn't directly map to a specific component of the finished product. Let me give you some examples to clarify this. So, if you're doing trenching along a road, you have a scope item called trenching. If that trenching for that specific task requires traffic management, I would classify the traffic management associated with the trenching as a direct cost. If you're working on a commercial construction project and you're going to have a traffic controller sitting at the entry checking deliveries for the entire 12-month duration, irrespective of any individual scope item, then I would call that an indirect cost. If you're doing concrete pour and you've got temporary works associated with the formwork for that, I would call those temporary works a direct cost because they specifically relate to the construction task. If you're building a temporary laydown area to store materials, it doesn't relate to a specific component of the finished product, I would call that an indirect cost. At the end of the day, it genuinely doesn't matter. At the end of the day, the only thing that matters is that you cover everything. Now, the next thing I want to talk about is that calculating overheads correctly is genuinely more difficult and involves more uncertainty than direct costs. The reason this is because unlike a concrete slab, your indirect costs aren't shown on any drawings and they typically won't be defined in the scope of works. The scope of works might say something like you have to attend construction meetings, but it won't say you need 1 project manager, 2 site engineers, and a project admin. At the end of the day, all of this stuff, if you miss something, it's on you. It's not on the drawings. It's not on the scope of works. So you're the one both defining the scope of your overheads and also estimating the cost. The other reason I think estimating indirect costs accurately is very challenging is often they are driven by time. Your project manager's salary is a function of the project duration. The duration of any project is more uncertain than the cost. Small errors in your schedule, the way you link tasks, the lead time for different items will drastically change the overall duration, which has this cascading impact on your indirect costs. Final thing is that a lot of these different buckets of indirect costs are independent with other items of your estimate. For example, if you're making an allowance for inclement weather, that's a function of your total labor hours. If you're making an allowance for trade coordination and delays from subcontractors, that's going to be related to your total subcontract costs. So your indirect costs are always highly dependent on your direct costs. And basically you get this cascading effect that if your direct costs are wrong, your indirect costs will be more wrong. Okay, so now we've clarified the different categories of indirect costs, how they compare to direct, and why it's just genuinely harder to calculate indirects accurately. I then want to give you a process to accurately do so. Very basic. We need to identify all of our indirect costs, and then we need to work out the values of them. So step one is to identify all the relevant cost items. This is going to be your responsibility. And as I've said, it's not going to be on the drawings. It's not going to be in the scope of works. If you miss it, you wear it. The very simple and straightforward way is you should have a checklist for all your projects that contains a superset of every possible indirect cost. You can create this by looking at historical project cost data, or you can look at your previous project invoices. So you get a superset of all the costs you've incurred to deliver the project. You can break those out from direct or indirect. The final way that I actually think is very effective is you can just use ChatGPT to help brainstorm for your scope, your specific type of work. What is a superset of all the possible indirect costs? Best practice for doing something like this would be to store all your indirect costs in a reusable workbook template. Obviously, this is a very simple one. It's just got some plant mobilization costs and an induction allowance for half a day per person. This is built in Opera, but you can really create any sort of Excel spreadsheet that you reuse. So this is a superset that you can use as a basis. I've broken it down into 4 categories of overhead costs. You've got your one-off costs at the start and finish of the job. You've got your recurring costs, which are driven by the duration of the project. You've got financing costs, which are value-driven costs. You've got labor hour-driven costs, and you've got subcontract-driven costs. Example of a one-off cost would be things like site mobilization, installing and removing the site sheds, permits, initial utility connections for the temporary buildings, any sort of like temporary laydown area, and any sort of final as-built condition reporting or commissioning support. Your recurring costs are the costs that are driven by the duration of the project. You'd have things like staff salaries, site office power, toilets, servicing, traffic control, security guards, cameras, rubbish removal. You then got financing costs. So these are things that are driven by the contract value. So things like bank guarantees, performance bonds, retention costs, finance costs associated with cash flow shortfalls, insurance premiums, and contingency for unknown unknowns. So typically you'd have some sort of black swan event contingency bucket, which is just a % of the overall project value. I'm calling these indirect costs, but you can also group them under risk and opportunity. And you've got your labor-driven costs. So this would be things like personal protective equipment, small tools, consumables, inclement weather allowance, toolbox talks. Then finally, subcontract-driven costs. The biggest one here would be subcontract coordination, a risk allowance, which would be done on the percentage of overall subcontract costs. Or if you're getting a lot of big deliveries, your logistics costs would be a function of when all these deliveries are happening. Now, as you guessed, the second step of this process after you work out what all your indirect costs are is you then calculate the cost. The way we calculate this cost is going to be a little different depending on whether it's a one-off or recurring cost or a value-driven cost, but I'll talk about the general principles and some shortcuts you can use to make it easier. So if I use the example of a one-off cost, say at the start of the project, you have to build and construct a laydown, that is going to be calculated the exact same way as you would calculate your direct cost for the task. So we've got 200 meters squared of laydown, we've got a quantity, 200 meters squared, we've got a depth, which is 200 millimeters, which gives us a volume, we've got a productivity for the clearing and grubbing, which gives us an overall duration and hours for the clearing and grubbing, we've got productivity for the placement of fill. We've got a total quantity of fill based on the area and depth of the laydown. From that, we can calculate how many hours of an excavator we need and how many hours of labor we need. Super simple, exactly the same way as you would calculate your direct costs. Now, for our recurring items, the critical input to this, so how long we need a project manager for, is the duration of the project, which As I've said before, scheduling is genuinely harder than estimating. So to create a perfect schedule is much harder than creating an estimate. So how can we do this in practice if we're time constrained? Well, ideally, we would have a project scheduler who puts in the same amount of effort as creating a schedule as we are going to put into creating an estimate. In practice, this isn't going to happen. So what can we do to make this easy for ourselves? In addition to just simply building a full schedule, we can also use the client's schedule. Ideally, the client will give us some sort of Gantt chart, mobilization date, durations, and so on and so forth. This is the best bit of information to rely on because when we submit our letter of offer, we can qualify in our offer that we have relied on our client's schedule and durations and sequencing. The only important risk to be aware of if you're going to do this is you need to look at the actual durations of the tasks, the quantities, your key production rates for the items where they are specifying the duration. Because if you were saying you're relying on their schedule, it implies that you're committing to the duration they've given you to do your work. Now, the reason I always say use the client's schedule is because if they're saying this is the date they're giving you access to do this work, then your cost is going to be reliant on this access date, which means that if you relied on that in your estimate and your proposal, gives you the option to claim delays for it later down the track. Now, the next way I like to do my schedule is if you're a self-performed contractor, so you're a formwork contractor and all you do is formwork, and so the duration of your project is going to be the duration of the labor component of your work. So for example, you're a civil contractor and you're doing bulk earthworks and you have 1,000 meters cubed to do. The duration of your project is proportionate to the quantity of work and the production rate and the number of crews you have on the job. So this is the labor hour method for estimating activity duration. You basically take the total labor hours for the project, divide it by your crew size and the weekly hours per crew to get the duration of the task. So if you have, say, I should have really written out an example of this, but I'm not going to be able to do it in my head. But say you have, for example, 2,000 hours of labor on your project. You have a crew of 4 people, which working a 40-hour week is 160 hours of labor per week. That is going to give you 2,000 divided by 160 is about 10, or no, it's probably about 15. That is then your duration of the project, 15 weeks, because you've got 2,000 hours of work. You're doing 160 hours per week based on having a crew of 4 guys, which gives you your duration. You can factor in a little bit more time for mobilization and demobilization, and that will give you a relatively good estimate of the project duration. Now, this works for self-performed contractors. It doesn't work for general contractors who subcontract out all their work. For general contractors who subcontract their work, your works are going to be driven by the critical path of the project. Scheduling, like anything, it's a little bit of an 80-20 process. You can probably make a really good estimate of the project duration with 20% of the work. The way to do that is basically for your project, and you have to understand the scope well, you basically work out roughly what the critical path is, then determine the rough duration of each of those tasks, and that'll give you a relatively good estimate of the duration. So if you're doing a building, it will be the site preparation, the earthworks, the concrete, the structure, the fit out. Based on similar projects you've done in the past, for those key tasks of similar size, you make an estimate of the duration, add a little bit of fat onto it, and that'll give you a relatively good estimate of the duration. Now, the final bucket of overhead costs, again, are going to be related to different variables within your project. Total project value is going to drive the cost of your bank guarantees, any cash flow financing, insurances, contingency, or design risk. Total labor hours you have for the project is going to drive your PPE costs, your small tooling costs, and your allowance for inclement weather. Coordination delays, scope gaps, procurement risk is going to be driven by the total value of your subcontract. So through the estimating process, you should calculate these key variables. Okay, so no one can tell you exactly what your overheads will be for your specific project, but here are some good rules of thumb. For a civil project where you're relatively large self-performed business and the cost of your supervisors, that's an important clarification, would be built into your direct cost, you've probably only got 10% overhead cost. It's probably relatively not a big management team managing project. If you're doing a commercial project, again, if you're mainly subcontracting out the work, it's hands-off managing it. Again, The overhead costs will be a small percentage of it. But if you're doing a remote fly in, fly out project where you've got to pay for accommodation, living away from home allowances, maybe even flights to get to and from site, you've probably got a bigger and bigger management team as the projects get bigger and more complicated. Realistically, you could have 35% or more of indirect costs related to direct costs. Now, the reason I'm against using these standard rules of thumb is overhead costs are just too large for a simple thumbs up exercise. When I see people doing estimates where they say, oh no, we just allow 35% on direct for our indirects, it just kind of doesn't make sense to me. What's the point of pricing your direct so accurately if your overheads you're just going to slap on another 30 or 40% and think that's reasonable? To me, it's just kind of pointless going through the whole direct cost estimating. So if you want to be accurate, you have to do your overheads properly as well. Now, this is why I think overheads is particularly important in addition to just improving the accuracy of your estimate. If you understand your overhead costs, how they're broken down and how they're driven, it will give you more opportunities to justify and claim variations during construction. If you understand the schedule, your client's access dates, when they're meant to give you access to site, what your recurring overhead cost is, you show this in your submission to them. You have a line item that says preliminaries, 14 weeks, they're late in giving you site. It is very easy to both claim and justify variation to them by simply adjusting the duration of the project. In addition to that, if they are delaying you and they don't seem to have any reason to push along the project, they seem to be ignoring you, you can use that as a lever to negotiate getting them to give you access to site earlier, and simply having them broken out in your price, qualifying in your letter of offer how many mobilizations and demobilizations you've allowed for, what duration of the project scope, what you're relying on them for access for to complete your task sequentially. It is going to make it so much easier to justify and claim change orders and variations during construction. So there is a strategic advantage to understanding your overhead costs. It's going to increase the accuracy of your estimates. It's going to increase your ability to negotiate and claim variations during construction. It's going to give you better control of your project, better cost tracking, better visibility of what your overhead costs actually are and what you can do to manage them. And you avoid one of the most common sources of underquoting, which is this big bucket of indirect costs and calculating it accurately. Every construction bid you submit is ultimately a bet on your business. We all know that one bad project can sink a construction business. Construction bids are built on assumptions. Production rates, scope interpretations, material price changes and escalation, and different site conditions. What makes this worse is the entire bidding process actually encourages contractors to make mistakes. Clients go out to the market, get 5 quotes for a package of works, and choose the cheapest one. 9 times out of 10, the cheapest price isn't the contractor with the best or smartest methodology, it's the contractor who is underestimated risk and uncertainty. So the goal of this video is going to be to give you a step-by-step process to review your estimates, eliminate avoidable risk, and submit your bids in a way that protects you commercially. So I want to first lay out a concept that I think you might find useful. There's really 2 ways you can fail at a bid. You can incorrectly estimate the price. I refer to this as the price risk, or the risk that the estimate itself is wrong. So there's things like incorrect quantities, unrealistic production rates, missing tasks in your work breakdown structure, subcontractor exclusions not picked up, or just incorrect labor plan or material rates. This is all about the estimating process where you take the scope, the drawings, the contract, interpret it correctly, and transform it into a price you do the work. This is all about the estimating process. Now, the other way we can fail at the pre-contracts phase is to have an issue with our terms. Basically, what this means is we misunderstood the scope, or we didn't qualify our price properly. Basically, we have priced something that didn't align. The other way we can fail at the pre-contracts phase is about our terms. Basically, we are quoting something and there's a fundamental mismatch between how our client interprets our quotes and what scope we've priced versus what we've actually priced. So this is things like in the scope of works, it says we're responsible for the disposal of spoil, and we haven't included that in our price. That there's a note about waterproofing buried on a drawing and we haven't included it. There's temporary works implied as part of the construction methodology. And in the scope of works, it says we're responsible for temporary works, but we haven't included that in our price. Or there's access, staging, program responsibilities that we haven't included. Basically, this is all about missing scope. And as I've seen in my career, missing scope tends to be a much bigger issue than necessarily poor calculations or errors during the estimating process. And there's really two sides to this. Did we price what our client was asking for? And if we haven't, have we qualified and excluded it? So basically the process I'm going to walk you through is how you, as far as reasonably practical, try to eliminate both these two types of sources of failure from your construction estimates. So if we talk broadly about the estimating review process and how I like to do it. So you start with your estimate, you do a sanity check, you do a risk review, you prepare a letter of offer or a tender submission, and then you submit it to the client. The estimating process, the risk review, the sense check, it's all about calculation errors. The letter of offer is how you cover yourself commercially. So the first step in this process, after you've prepared your construction estimate, is you really want to be comfortable that the scope of works you've priced is the correct scope of works. Fundamentally, do you and your client agree on what you're pricing? And if not, you'll need to qualify that in your letter of offer. This just comes down to having read the full scope of works, not just pricing schedule or looked at the drawings, being able to clearly state what's included and excluded from your price. Does your interpretation on the work match your clients? Have you spoken to them about it? Have you clarified any ambiguities and documented them? And if they've issued new revisions of documents, is this what your estimate is based on? Because if you and your client are having different interpretations of scope now, by the time it comes to construction, administrating the contract, you will almost certainly have issues. Now, sometimes these issues can go in your favor and you get variations, but a lot of the time they won't. So once you're sure you understand the scope of what you've priced, there's no ambiguity, it's clear and aligned. Next step is to do a logic and sense check on your estimate. This is really a high-level sanity check that your price makes sense. The way I like to do this is first to look at the overall work breakdown structure of the project and basically make clear that everything is either included or excluded from your price. The second thing I like to do is to look at the rates for each of the key items. So these are things like dollars per meter cubed of concrete, dollars per linear meter of trenching, or dollars per megawatt for a solar farm, and basically to make sense that these benchmark rates are correct. If your dollar per meter cubed of concrete is a dollar per meter cubed, you've almost certainly got a calculation error somewhere. If a rate is 50 or 100% out from your historical cost rates, then you've likely missed scope. Now, the next check I like to do, which will only work for self-performed businesses, is does your labor or man-hour estimate at a high level align with your program? For example, if you've come up with 2,000 labor hours for a project, does that align with, if you have one crew on the project, 10 weeks of work? These sort of program-based estimates are a very good way of taking big numbers in your estimate and getting them to make sense. You can apply the same logic to your indirect costs. Typically, if you do projects where your indirect and overhead costs are 20 to 30% of the contract value, that's a very easy check to do. Or do they align with the duration of the program in the man hours estimate? And then the final one is to check that your contingency matches the type of contract and the risk. So once I've done the estimate logic and sense check thing, the next thing I like to do is to do the 80-20 check. This is basically to look at your price, look at what are the key things that will make up 80% of the cost. Because the reality is not all costs are going to be equal, and you really want to spend most of your time reviewing the big assumptions and the big costs that make up the majority of your price. There's a saying I love, which is it's better to be roughly correct than precisely wrong. I've known estimators that will spend ages going through a list of PPE to work out the exact rate to allow per employee when this is massive assumptions in their bids that they haven't properly qualified. The key message I want to drive home here is you should spend most of your time reviewing the top 5 to 10 cost drivers and any key assumptions. Likely, they're going to be things like key productivity rates for a specific task, or things like your labor rate if you're mainly a self-performed business. Next, if you're a general contractor or subcontract out a lot of the work, you should do a specific review of your procurement. When reviewing your procurement, there's really two things you want to check. Do you have a proper work breakdown structure? Are your packages divided up correctly? Are the scope interfaces clear? And the second part of this is once you know you've got a comprehensive work breakdown structure, you've got all your packages set up properly, that your individual quotes that you're including in your estimate, have you properly budgeted and allowed for inclusions and exclusions? Because every subcontractor, when they price something, will have inclusions and exclusions. And if they don't align with how you've allowed for their quote, you will have gaps that come up and manifest as variations during construction. If you've got a lot of materials and logistics, you should do a check of all your pricing around these items. Have you just allowed for the construction quantities, or have you also got waste, spares, other items in there? Have you factored in delivery and handling, storage and double handling if you're going to stockpile items on site, lead times and its impact on the program, and importantly, escalation and price validity for key supply agreements. Next, you should look at your planned and temporary works. And I always talk about when I'm estimating plant costs, it really comes down to understanding the schedule. If you're dealing with big plant like cranes, how many mobilizations are you allowed for? Does it match the construction sequencing? Then you want to check your commercial terms and your risk alignment. Are there any specific contract terms or conditions like high rates of liquidated damages or an extended defect liability period that you need to allow for separately? Then once you've done a check on your own work, you should get somebody else to review what you've done. And that's why I always say when you're preparing a construction estimate, you should always document your assumptions and you should make your working very clear and easy to follow, because it's just going to be much easier for someone else to look at it and find errors and inconsistencies. I know I personally find it hard to check my own work because you've got all this background information, how you put it together, and you can leap over important assumptions you've made. So if you get an independent review of your estimate, it's likely going to unearth some big issues if you have big issues in your estimate. Now, the final part of this process, we've got our price, we've made sure we've understood the scope, we've checked our estimate, we're comfortable with our price, someone else has looked at it. We need to package this up and submit it to our client, and that is why we need to prepare a letter of offer. A letter of offer really takes your assumptions and risks surrounding your price and translates this into a commercial position. What are you actually quoting to do? You want to spell it out so it is unbelievably clear for your client. What are you quoting to do? What information is your price based on? Every company should have a standard list of inclusions and exclusions for the type of work they do. It should be updated regularly with issues that are coming up from projects. So here's an example where you have a template letter of offer, which includes the inclusions and exclusions and a breakdown of the quote. It lists out what we've included, that we've based our quote on the 10-week project duration, probably coming from our client. It explicitly states what work we've priced to do, and it lists out all sources of potential exclusions. The most important part of a letter of offer is to clearly state your inclusions and exclusions. It should match how your pricing is done, explicitly lists the price scope, and it highlights any gaps and ambiguities. Your key assumptions as they pertain to the client should be stated clearly. Now, obviously, if you're a self-performed business doing concreting works, you can't qualify the production rates you've used because those are always going to be your risk. But if your client has specified, for example, they've given you a bill of quantities and you've relied on that information, I would document that in my letter of offer. If you haven't allowed for things like material price escalation, unexpected delays, or you've based your price on the number of mobilizations they've stated in their tender documents, all that stuff should make it through to your letter of offer. Importantly, the letter of offer is really the basis for how we negotiate between when we submit a quote to when we sign a contract. Now, our client will have sent us a scope of works with their inclusions and exclusions. They're almost certainly not going to match our letter of offer. Every contractor quotes work slightly differently to what their client asked. So as we go through and negotiate our price, we get to a position where we sign our contract. What we really want to do is we want to close out all of our inclusions and exclusions and get them to exactly match the scope of works we're signing with our client. This may require us adjusting our price. It depends what our client is happy to accept or not accept, so that by the time we sign the contract, our price and our terms and conditions exactly match, and it's reflected in the client's contract. At the end of the day, every major construction bid is a bet on your business, and if it's a bet on your business, you should be 110% confident that you've done everything possible to reasonably reduce risk. To finally wrap up and finish this course, I want to talk about how you take this estimating process, everything we've talked about, and basically apply it to the type of bids and projects you're working on. A framework is universal, but the execution, how you follow the process, is always going to be specific to types of projects you're working on. So really, the overall process isn't going to change, that it involves turning your tender documents into a price and terms and conditions. It's about understanding risk and variability. What is going to change is where the risk sits, how much risk you're taking on, how much time you have to prepare your tenders, what accuracy matters most, and basically where you're spending your time and effort. I'm also going to try and keep this super brief because I think most of these insights are relatively intuitive. And when you actually start going through the estimating process, you're going to see that it is fundamentally different for different types of businesses. The first key customization will be whether you're a head contractor, whether you're signing the contract with a project developer, or whether you're a subcontractor and you're negotiating and signing a contract with a head contractor. So head contracting, you're the ones carrying end-to-end project risk. You're often responsible for the design. So most head contracting is detailed design and construction. You're responsible for the overall program, interfaces between trades and coordination. You have both the negative, that tenders are going to be more complex and high effort, but your clients are likely more sophisticated and they care about things like your methodology, your program, your capability, and reputation. You're going to also have more time to put into the estimating process. You can have a better risk identification and allocation. You can spend more time reviewing and negotiating the contract, clearly clarifying scope, aligning your price, program, and contract terms with the offer you're making, and also, because most head contractors subcontract most of the work, aligning that with your supply chain and procurement to de-risk your tenders. For the head contractor, estimating is as much about risk management as it is about pricing. It's not necessarily going to be a race to the bottom. Unfortunately though, for subcontractors who are pricing work to general contractors, the reality is general contractors, all they care about is money. So they're going to be much more focused on clearly defining scope. They're not going to accept many changes to the scope. Going to be getting 5 quotes and they're going to be finding the cheapest price. Therefore, the subcontractors, while the tenders are going to be less complicated and less effort, it's often much more about price. So when you're talking about the estimating process for subcontractors, it's going to be much more about having reusable activity templates, pricing the same task over and over again, maybe just adjusting the quantities for the project and the production rate for different task complexities. And you're going to have things like custom spreadsheets or tools that do this. The other difference is, while for head contractors, they would typically have a dedicated project management team, for subcontractors, it's much more about shared overheads across multiple projects. And estimating is really about speed, accuracy, and consistency. Now, the next split we're going to talk about is for businesses that primarily subcontract versus self-perform, which actually more or less matches head contracting versus subcontracting, with subcontracting businesses tending to largely self-perform, head contracting businesses tending to sub everything out. So for subcontracted delivery, most of your effort is really going into the procurement process. You're taking the head contract requirements that you're responsible for, breaking these down in a logical way to get the best value for money, then passing on your head contractor risk to your subcontract risk. Most of the issues you're going to run into in the estimating process are going to be scope gaps between subcontractors, assumptions around quotes or inclusions and exclusions that you missed, and incomplete subcontractor coverage. Majority subcontracted delivery is much more about contract management. Basically, have you properly transferred all the scope you're responsible for to your subcontractors? Self-perform estimating again, this is pretty much similar to the head contract subcontract split, but for when you're self-performing the work, it's much more technical. It's much more about accurate quantity takeoffs, getting the right methodology, and then plan and productivities to reflect that, and making sure you're fully utilizing your resources. The risk is going to live in your productivity assumptions, your methodology assumptions, the access and sequencing, things like temporary works. It tends to be much more technical than it does purely commercial. The next split are commercial projects, so maybe large commercial construction projects or smaller commercial and residential projects, and infrastructure or civil jobs. Commercial jobs tend to be lower margin. They're more repeatable, consistent projects. I mean, one building would often look different to another, but the actual construction process is relatively similar. There tends to be a much higher level of standardization, lower technical uncertainty. Again, commercial construction are going to benefit more from reusable templates, benchmarking, and rate libraries. It's more of a focus on efficiency and consistency. Infrastructure projects tend to be higher margins, more messy, overcomplicated. They tend to be more focused on non-standard one-off jobs. Tends to be more uncertainty and risk management, such as ground risk, access risk, or challenges with logistics. And it's really about understanding how the job will be built before pricing it. Again, big versus small. Big companies are going to have more complicated projects. They're going to have full-time estimators and contract management. They're going to have more structured review processes. Small companies, it tends to be about more fast, repeatable, template-driven. The next one I would talk about, which isn't a split between big versus small, because I've been at big companies that have terrible data maturity, and I've been at small companies that have very good systems to track productivity and cost. But basically, it's how good is your input data. Obviously, the tender package you can only do so much about. Depends on your client. But even small contractors can set up estimating systems where pricing is driven by historic cost. They've got lessons learned about commercial exclusions or inclusions and issues they run into, and they build this into an estimating process. Basically, if you have a high data maturity business, their risk is managed through accuracy, not guesswork, when low data maturity tends to be more about a risk management approach where your risk is absorbed through higher margins. Ultimately, what this means is you basically want to customize your estimating process to the types of projects you're working on. If you're a small subcontractor pricing the same thing over and over again, you should invest your time in building templates that make it very easy to price fast and accurate. If you're a big construction company bidding on large complex projects, obviously your focus is going to be on risk management and the overall estimating process, how you feed the detailed design you're doing into the estimating flow. So really it's about understanding basically these differences and building an estimating process that reflects the type of project you're doing.